Yes, on. Yes, please.
Bismillah ar-Rahman ar-Rahim. Ladies and gentlemen, welcome to the PISTAR celebration of the World Statistics Day 2020. On behalf of ISOS and PISTAR, and on my own behalf, it is indeed a privilege to welcome you all to this very special online event. We have gathered here today in this virtual hall, I should say, in order to celebrate the third World Statistics Day announced by the United Nations. As you know, this is the logo for this year, and the theme is connecting the world with data we can trust. And I'm quoting some of the things which are on their website. So it says that the third World Statistics Day is to be celebrated around the globe on 20th of October 2020 with this theme. And this theme reflects on the importance of trust, authoritative data, innovation, and the public good in national statistical systems. World Statistics Day 2020 campaign. The celebration of the World Statistics Day 2020 is a global collaborative endeavor organized under the guidance of the United Nations Statistical Commission, the Statistics Division of the United Nations Department of Economic Affairs is the global coordinator of the campaign, defining global key messages and making available outreach resources to countries and other partners. National statistical offices act as national coordinators, translating promotional materials into national languages and organizing events and outreach efforts at national and subnational levels. International organizations play a key role in amplifying campaigns at the global and regional levels, and also organizing their own events. Ladies and gentlemen, here at ISOS and PISTAR, we decided to celebrate the third World Statistics Day through an online program containing a galaxy of renowned statisticians from a number of countries located in different regions of the world. It is very exciting, not only for me and my team, but also for colleagues and students for belonging to various organizations and higher education institutions here in Pakistan. More than 60 colleagues from within Pakistan and 24 colleagues from 12 different countries of the world have registered, and hopefully they are right now with us or will be joining us within the next few minutes in order to be a part of the PISTAR celebration of World Statistics Day 2020. So we have Afghanistan, Argentina, Germany, Iran, Iraq, India, Indonesia, Italy, Kenya, Malaysia, Tanzania, and Turkey. And these are the ones who are attending. And in addition to them, we have so many invited speakers, our honorable guest speakers from various countries. From Pakistan, 62, and a total of 86. And these does not include me and my team and ISOS team. So obviously, it is a big day for us today. So now I would like to, in a short while, invite the president of ISOS, Professor Dr. Mohammad Hanif, to address the audience and to give his welcome address. But prior to that, I would like to present to you a short summary of his academic and professional achievements. Dr. Hanif accomplished his MSc from Punjab University, MPhil from New South Wales University in Australia, and PhD from Punjab University, Lahore, Pakistan. He taught at Punjab University. I would like to request everybody to please mute their mic. And Dr. Wasim, you can mute the mics and then just keep my mic unmuted so that there is no disturbance in the recording.
Yo.
Dr. Hanif taught at Punjab University, Karachi University, University of Tripoli in Libya, King Faisal University, Dammam, Saudi Arabia, LUMS at Lahore, and at present, he is the acting rector at the National College of Business Administration and Economics right here in Lahore. He also did visiting professorships at various universities that you can see. Ladies and gentlemen, his total teaching period is about 60 years. He has supervised 63 PhD students. He has published more than 300 research papers, and he is the author of 12 books. I now present to you Professor Dr. Mohammad Hanif. Sir, you may please begin now. I will escape and also stop sharing. Yeah, now you can share Dr. Saib's screen and you can begin, sir.
Honorable guests of the world, and on behalf of the Islamic Society of Statistical Sciences and PISTAR community, and on my behalf, I welcome the statistics fraternity to celebrate the third World Statistics Day announced by the United Nations. In particular, I would like to welcome the renowned statisticians from various countries of the world who have joined us today in spite of their tight schedules. Next, please. As many of you are already aware, the United General Assembly in its 61st session passed a resolution and asked the United Nations Statistics Commission to celebrate the World Statistics Day on October 20th, 2010 for the first time, for the promotion of national statistics and for improving their quality and comparability. 103 countries celebrated World Statistics Day at this occasion. In Pakistan, the first World Statistics Day was celebrated by Islamic Country Society of Statistics Sciences through a walk that was led by late Professor Dr. Munir Ahmad, one of the most eminent statisticians of Pakistan. Islamic Country Statistical Sciences stands for the Islamic Country Society of Statistical Sciences that was founded by late Professor Dr. Munir Ahmad back in 1968 and has made a significant contribution for the development of statistics and statisticians. Let us pray for their departed soul. May God bless in an eternal peace. Next, please. The walk held on October 20th, 2010 extended from the National College of Business Administration to Tevita Secretariat in Lahore, Islamic Country Society of Statistical Sciences, and government officials from statistics divisions, Population Census Organization, Agriculture Census Organization, Punjab Statistics, Superior University, Canadian College Lahore, National College of Business Administration and Economics, and Shah Abdul Latif Bhai University, Khairpur, Sindh, joined the World Statistics Day walk. Next, please. In fact, Islamic Country Society of Statistical Sciences had arranged a week-long program from October 18th to 22nd, 2010 in connection with the World Statistics Day. The programs included a statistics festival arranged by the Canadian College on October 18th, 2010, a one-day seminar on development of statistics in Pakistan organized by the Lahore College or Women University, on October 19, 2010, and two-day session arranged by the Department of Environment Management Sciences under the guidance of late Dr. Khurshid Ahmed at National Comics, Lahore. Next, please. In fact, the second World Statistics Day was celebrated on October 20th, 2015 in over 130 countries around the world. It remained a tradition with Islamic Country Society of Statistical Sciences to celebrate World Statistics Day each time. The second one was celebrated at Asas House on October 20th, 2015. Islamic country statistical sciences have always been coming up with the ideas regarding generation of new areas in official statistics that one directly used for planning. Statistics can be used very effectively for planning, monitoring of performance, and other important aspects of the governance. Islamic Country Society of Statistical Sciences expressed its desire and commitment to promote their effective role of statistics while celebrating World Statistics Day for the second time in 2015. Next, please. Next. Can you hear me? The Pak Institute of Statistical Training and Research, which we call as a PISTAR, was created by Professor Dr. Munir Ahmed in 2017, just 3 years ago. It is closely affiliated with the Islamic Country Society of Statistical Sciences, and today you are joining us for the PISTAR celebration of World Statistics Day 2020. The theme of this year's World Statistics Day is connecting the world with data we can trust, is benefiting challenges that the world is facing today. Any country can create trust through data and statistics based on truth. At the occasion of the third World Statistics Day, Islamic Country Society of Statistical Sciences expresses its firm commitment to play its role effectively, to plan for the acquisition of data, and that is reliable and valid to create trust, and is directly useful for policy making, implementation, and evaluation. Next, please. I once again thank you for all joining us today in spite of your heavy schedule. I hope you will join the invited talks to be given by the eminent statistician from around the world, followed by the panel discussion led by Professor Angel, President of the International Association of Statistical Education. At the end, I would like to thank Dr. Naghmi, Habibullah, and her team for organizing this online event, the first time its kind in the history of Islamic Country Society and PISTAR. Thank you. All the best. Thank you very much.
Thank you very much, sir. Thank you very much for this. And ladies and gentlemen, I will now once again share my screen. Dr. Wasim, are you able to share my screen for me, or do I have to do it myself every time?
Dr. Saleha, you yourself share the screen.
All right. Okay. Okay. I thought maybe you have some capability of doing it, which I don't know too much about.
No.
But now I've done it. All right. So many thanks to Dr. Mohammad Hanif, my teacher. And now we begin the exciting series of invited talks by our distinguished guest speakers from various countries, including Pakistan, who are renowned experts in their respective subdisciplines of the field of statistics. So first of all, I would like to invite Mr. Sadid Rasool, Director General of the Bureau of Statistics, Punjab. Mr. Sadid Rasool I hope he has already joined. And before I invite him to actually start presenting his talk, I would like to give you a short summary of his achievements. So his education, MPhil in Statistics from Allama Iqbal Open University, Islamabad in 2007. Masters in Statistics from Punjab University, the most well-known and one of the oldest universities in this part of the world. Placed in the first division throughout his education. And then the foreign training courses he's done, the fellow of first group training course in modules on fundamental official statistics from the UN Statistical Institute for Asia and the Pacific, UNSIAP, Tokyo, Japan in 2006. And then the special field of interest during the training abroad was, for him, survey methods, national accounts, and social statistics. Overall, his performance was very good and in the upper quartile. I really like this statistical way of saying it. So then he participated in a technical training on this multiple indicator cluster survey, which is one of the very, very important surveys that is carried out by the Bureau of Statistics, Punjab. By the way, Dr. Wasim Abbas, the focal person of this particular program, is also assistant director of exactly this very bureau. So, you know, this mix is one of the most important surveys that they do. So you can read the rest of it here, but this particular training was held in Thailand. And then he participated and presented the survey presentation of an international project, Innovation in the Textile Sector in Punjab, at the University of Oxford last year, just about 1 year ago. And what else? This is going in the backward chronological order. Technical training on child labor data analysis and reporting in Italy, and this other one in Beirut. The UNICEF Mix 6 survey design workshop. And there are so many more, and as you can see in the bottom, I've written more. Then let's talk about these research publications. I think in Pakistan, we don't find too many people who are not in the academia publishing papers. I think this is commendable. Comparison of safety first rule and cluster analysis for evaluating wheat genotypes with significant genotype environment interaction, and in the Pakistan Journal of Agricultural Sciences. And the other one you can read, ladies and gentlemen. And then there's some more. This one is on maize. I think he's very much interested in agriculture, among other things. And there's so many more publications. He is Director General, as I said, at this point in time, of the Bureau of Statistics, Punjab. And he has obviously multifarious responsibilities, including the conduct and completion of all these important surveys that are carried out. In Punjab, the largest province of Pakistan, population-wise. I present to you now, ladies and gentlemen, Mr. Sajid Rasool.
Thank you, Dr. Saleha. Everybody can hear me?
We can hear you,
Hello.
but how do we, Dr. Wasim, how do we enlarge the, if we just do the speaker view, ladies and gentlemen, everybody may click on the speaker view on the top right of my screen, maybe on yours also it is on the top right. So then you can see Mr. Sajid Rasool, because he is not doing a slide presentation. Yes, Mr. Sajid.
Thank you, Dr. Saleha. Good afternoon to everybody. I'm Sajid Rasool, definitely a very well introduction by the Dr. Sahiba. I am really grateful to the PISTAR and on the platform of the Aisha, who is going celebrating and organizing this such a very wonderful event on the day of the celebrating of World Statistics Day. my discussion about the importance of the reliable statistics in key aspects for good decisions and planning. As you know that I'm working in the public sector, so my concern is about how statistics is more important and can provide a more impact about in the decision making and policy making. The field of statistics is a science of learning from data. Statistical knowledge helps to use the proper method, collect the data, employ the correct analysis, and effectively present the results. Statistics is a crucial process behind how we make discoveries in science, make decisions based on data, and make predictions. Statistics allow you to understand a subject much more deeply. The increasing demand for more and better statistics has brought to the front position the importance of statistics as a strategic resource for national and international development. Statistics are now recognized internationally as a part of an enabling environment for the development and constitute an essential element in improving the ability of the government to develop appropriate policies, manage the economy and social development reform, monitor improvements in the living standards of the people, and report back this progress to the public using solid evidences. According to the World Bank, good quality statistical data are needed to manage results, to set targets and monitor outcomes, to design development policies and strategies, to make evidence-based decisions about allocation and management of scarce resources. Good decisions on effective policies, services, and behavior require timely, accurate, and relevant information. Yet there is a striking disconnect between the need for information and the ability to respond to that need, to collect, collate, analyze, and communicate the necessary information in a timely and understandable fashion requires organized processes and procedures. The statistical methods and procedures are useful for socio-economic development. Statistical methods are applied to enormous numerical facts with an objective that behind every figure there is a story. Thus, it can be used in a diversified field of study. Personally, I think statistics is an exciting field about the thrill of discovery, learning, and challenging your assumptions, and facilitates the creation of new knowledge. Statistics are not just number and facts. Statistics allow you to evaluate claims based on quantitative evidence and help you differentiate between reasonable and dubious conclusions. Statisticians offer statistical guidance in producing trustworthy analysis and predictions. Along the way, statisticians can help investigators avoid a wide variety of analytical traps. When analysts use statistical procedures correctly, they tend to produce accurate results. In fact, statistical analysis account for uncertainty and error in the results. Statisticians ensure that all aspects of a study follow the appropriate methods to produce trustworthy results. We have to improve decision making with statistics. We make decisions all the time. Often our decisions making is with little more than a gut feeling. When faced with a major decision, we often look data to help us to decide. We have to encourage the use of statistics. If nothing was uncertain, we would not need statistics. Since nearly everything varies in some fashion, we need a way to describe and work with that variability. We already know about statistics as being a right set of tools that can measure the variation correctly. Please encourage and support the use of statistics. Basically, expect the use of statistics to design, conduct, and analyze experiments, do experiments to learn and reduce uncertainty. We would say, let the data talk. So this is my last words about my discussion. I would also like to share about the activity what we have to plan for celebration of this World Statistics Day on the 20th and 21st of the October. Punjab Bureau of Statistics, as already shared by the Dr. Saleha Habibullah, that is a provincial great populated province of the Pakistan and has a provincial statistical organization which is a central premier statistical organization. And this time we plan to organize this World Statistics Day by conducting a symposium in the Planning and Development Board on the 20th, in which very well known personalities of the statistics community are invited to share their deliberations about the importance of the statistics. And very next day, on the 21st of the October, we also have a plan to make the exhibition of the poster on the theme of the World Statistics Day, that connecting the world with data we can trust. So from my side, once again, I am really pay the congratulations to the PISTAR on the platform of the ISOs who have conducted this very wonderful opportunity to share the opinions at the international forum. Thank you once. Thanks.
Thank you very much, Mr. Sadid Rasool. This was excellent. Thank you. I will now try to share the slides again from my side. Okay, I think I've been able to do it. And now the slideshow. All right. So this was the invited talk by Mr. Sadid, and many thanks to him. And now we proceed to the invited talk by Professor Andre Blake, who is professor at the Department of Biology in the National Institute of Biology in Slovenia. Before I invite him to start presenting, I would like to share with you his achievements. He's a full professor of biostatistics at the University of Ljubljana and a senior researcher at the National Institute of Biology, both in Slovenia. Currently, he is involved in the analysis of high throughput and genomics data. He is interested in the use of computer simulations and interactive animated graphics for statistics teaching. Andre has been the president of the Statistical Society of Slovenia from 2005 to 2016. He's been the vice president and the president also, of course, until 1 year ago, of the International Association for Statistical Education. And he's also a council member of the Federation of European National Statistical Societies ever since 2011. And the rest you can see. And of course, he's also an elected member of the ISI, the International Statistical Institute. Professor Andre Blake received the Teacher of the Year Award in 2005 at his home university, the nationally prestigious Blake Award, named after his father in 2016, from the Statistical Society of Slovenia, the Z Award for the lifetime achievements in the research fields covered by the National Institute of Biology just 2 years ago, and the IASC Appreciation Award in recognition of exceptional service to IASC and the Statistics Education Community in 2019. Ladies and gentlemen, I present to you Professor Andre Blake. Andre, would you like to share the screen from your side?
Yes, I'm trying to share it. Excuse me. You have to turn off the presenter mode, which I don't need.
Andre, I cannot hear you properly.
Okay, can you hear me now?
Yes, yes.
Yes, and do you see my slides?
Yes.
In full screen, I hope.
Maybe you can do the slideshow.
Yeah, I'm trying to. I apologize. I'm not very versatile in this. Okay, but nevertheless,
don't worry. On my side,
Okay.
also, you know, many times the slideshow, when I do the slideshow, it gets stuck if I'm sharing the screen. So if you cannot do it, it's fine.
Okay. So thank you. First of all, thank you for inviting me to this celebration of World Statistics Day. Thank you, Saleha, for considering me. And well, I'm happy to see all these participants here, at least on the list. So not to waste too much time, I will just try to tell you my thoughts about the skills that are needed for modern day statisticians. And of course, we all know the position, and in the previous presentation, the position was already mentioned as very important in all aspects of human life. So in present days, of course, the involvement in statistics in the health issues and the governmental issues is maybe overemphasized, but in science education, it also has its important place as ever. So what is where is the position of the statistics and statistician in the society? I think that it's in minimizing and controlling the uncertainty, which was already mentioned in the previous talk. And especially important nowadays is to avoid biases, the trust in statistics numbers that we have about this uncertain, unhappy situation about the current pandemic is how to avoid bias in all our data collecting and reporting. And again, in the modern time, as you see, we have to give results in reasonable time. Every 24 hours, we need to provide new data. So there are certainly some skills and some need for statisticians in modern time. But the times change. Times that were in the past were like riding on this cart. There was a lot of time to think about the data. There was a lot of time to think about the results and how to report them. But nowadays, things are really, really much faster. So data are many times acquired automatically. Size of data is enormous. It's exploded in the last few years. And of course, there's no time for 10 years for census. If we will report about this pandemic in next 10 years and not now, it's already hopefully over. So where is the position that I see of statistics in the society? Well, the statistics is the science of uncertainty. This, for me, it's the most important part. Uncertainty is something that other professions and other sciences are maybe not able to cope with, but uncertainty is something that statisticians are really trying to minimize, and that's our bread and butter of our work. So, but in this reasoning is not of course enough. We have to communicate well. We need to be versatile in visualizations. Statistical computing, at least for me, I'm more computational statistician, and it's more, maybe it will be a little bit overemphasized, but nevertheless, this is my view of the problem. We have to cope with different sizes and different sources of data. In reproducibility in the modern times, the fake news are somehow acceptable. I don't know why, but it is so. But in science, or at least in our work, the research and data should be somehow, the results should be reproducible. And of course, we have to produce the times in reasonable time. About reasoning or about uncertainty, it's something that we are doing all the time. We are teaching our students how to reason about uncertainty. We are somehow trying to develop methods that will in a way minimize variability or explain variability, explain the sources of uncertainty. This is something that maybe is no need to talk about in the audience of such eminent statisticians, but maybe the other things. Communication. I'm not the best maybe in these communications in the modern ways, but anyway, we have to communicate our data and results with clients. We have to communicate with general public. This is especially important. We have to use modern ways of communication and promote our work and methods and results. That's something the skills that we need to develop also in our students. Years ago, Brian Ripley, in one of the conferences that I organized, statistics plus marketing equals data mining. That was, the marketing was somehow considered in different way that I will use it here. And this marketing is marketing of our work through scientific papers, marketing on the web, on blogs and Twitter. And this is the point that I refer to, that I'm maybe not the best. I'm not tweeting, I'm not blogging, but I see a great potential and great need to use these different channels of communications to promote our data. Maybe I'm a little bit better in open source software, R packages. My work is somehow promoted through R packages that are maybe helping other people to use my work.
Andre, there is a request that you may do the slideshow. So just if you could try one more time, maybe it will work.
Is it better now?
Yes, yes. Now we can see this.
Okay, sorry.
Thank you.
Many screens. Thank you for reminding me, and I apologize. Well,
no problem.
Some of you attended the ICOTS meeting in Ljubljana in 2010. It was mentioned as a very, very warm and hot place, but it was hot also for statistics. Hans Rosling, who was invited speaker at that time, showed these two pictures. These are two pictures from his talk, and they are sounding in me all the time. It's he claimed that to pass the music to general audience, it's not enough to have the notes. In addition to notes, you need to have musicians who can somehow play it to the general public. And visualizations is something similar in statistics. Our results in tables, or maybe results that are too technical, are good for us, for professionals, but not for general public. So we need to develop visualization tools, and we need to be able to visualize our results in a way that public will understand better. I will show you a few examples of bad visualization. This is the first and only, I think, visualization of confidence interval in our national broadcast television. These are pictures of confidence intervals. These are not intervals. The interval is here. So it's completely wrong. They even calculated these intervals, but they miscommunicated them. Recently, they showed this trend of the number of cases increasing drastically, also in our governmental reports. But they had just two numbers, so it's somehow really bad communication. But it happens in other places too. Is the number of citation counts for the PLOS for the research paper. But if you look carefully, your paper can be -10 times or -3 times cited. So and they know that it's wrong, but nevertheless they publish this thing. So results are somehow just for one day. They are obsolete very soon. So we have to be careful not to do that. So coming to statistical computing, we deal with a lot of different hardwares, at least if you go more to the history, and a variety of software. On the hardware part, allow me just to show few of machines that I went through in my career. And of course, now we have these laptops and things that look a little bit similar to that. So we have to be adaptive. We have to be prepared for future softwares and future hardwares. Many statistical packages, many statistical systems are available, but nowadays somehow all this focused probably to R, which is a very important tool which has to be taught to all students. And I'm very happy to see that PISTAR launched the lectures and courses, workshops on using tidyverse and R. I'm really happy to see that, and I congratulate you to have this support for future generations. Big data are very complex. This is difficult to cope. The traffic is not organized like this, but more like this. And also data are becoming messier and messier. So we have to be able to get the data quickly from the messy web-based resources. In programming, it's also, again, to R. I think that statisticians need to know at least basic programming skills to help them to go through the data that are available today. We will hear something about the machine learning and the difference between statistics and machine learning today, but this is a nice representation of what we need if we want to be today somehow competitive and expert. We need also substantive expertise in addition to hacking skills and statistics that we have. So R, again, is reproducibility. If results should be reproducible, we have to be very careful to use tools that are available. And the very last important time is produce results in reasonable time. We have real-time online collections of data, which can become obsolete after 24 hours maybe. So we have to be really, really fast. And this is the summary of the skills that I mentioned. And the most important is understanding of uncertainty, because other professionals maybe don't understand all this that we do, and we have to take it to advantage in the use of all other skills that I think are important for us. Thank you for your attention.
Thank you very much, Andre. That was wonderful. Thank you so much. Ladies and gentlemen, I know you have questions. I also have a question. But since we are, not according to our schedule, so I will request everybody to jot down their questions. And later towards the end of the program, when we have the panel discussion time, maybe somehow we will fit in all these questions at that time. I would like to thank you for your patience, and on the invited speakers too. Thank you so much for this, but I think we will need to, have the questions at the end, because it is already 2:52, whereas according to my schedule, the next talk is supposed to start at 2:33. So it is not nothing to do with the speakers. It is all my problem, my own responsibility. So thank you very much, Andre. Ladies and gentlemen, I will now once again share my screen and share with you the next talk. The lady who's going to present the next talk, Professor Aisha Bilgham, who is an associate professor in Sydney, and she's the president-elect of the International Association for Statistical Education. She is at Macquarie University in Australia. So before I invite her, I would like to share with you her achievements in life. She's active in the statistical analysis and in the design of studies in health and statistics education. Her research in health developed to include adolescent health and recently studies related to breast cancer, MS, and Alzheimer's disease. She is one of the pioneers on applying machine learning to health data sets. So this is very good, because Aisha, I think I'm going to invite you to give us a workshop on machine learning, maybe in a few weeks or a few months' time. Because here in Pakistan, so many of us statisticians are wanting to know what this thing is all about. We keep hearing about it, don't know too much about it. Sorry for the informal statement in between, but I thought I should say it right now. So Aisha is one of the pioneers on applying machine learning to health data sets. And recently, ladies and gentlemen, she was awarded Excellence in Research, 5 Future Shaping Priorities for Healthy People by the Macquarie University. Aisha has won several learning and teaching awards for her outstanding contributions to student learning, such as ALTC citation for outstanding contributions to student learning. Her pedagogical research interests are focused on statistics education, such as learning approaches in statistics, impact of learning spaces to students' learning. As I have already said, she is the president-elect of the International Association for Statistical Education. Ladies and gentlemen, I present to you Professor Aisha Bilgham.
Thank you, Saleha, for inviting me, and thank you for the nice introduction. I'll try to build on what has already been said. And I am going to concentrate on the topic that I said I'm going to talk about, which is online assessment for large first-year service unit, challenges of COVID-19. Why did I want to talk about more specific assessment-related thing instead of more general theme? It's because I noticed, and I was talking to one of the previous presidents of IAC the other day over the phone, and I noticed that I am concentrating, always thinking about the assessment. And I'm also thinking about how we can get more students to study statistics. So what I'd like to actually say is we have a problem. I don't know whether you have it in your countries as well. We have a problem that we are short of statisticians, and we need more students studying statistics, and we have lots of students studying first-year statistics because they're doing marketing, they're doing health sciences, psychology, and their professors force them to study statistics as part of their degrees, but they stop doing any more statistics after they've done the first year statistics. I am one of the lucky ones who is actually teaching now that thousands of students who don't want to be in my class, who believe that I am the devil who would like to punish them for some reason or another, and they want to get out of the class as soon as possible. But in that class, what do we want our students to learn? Because my students look at my lectures and say, what am I going to do with that? I just have to memorize it. There's no use for it in my real life. I'm going to be a marketer. I'm going to be a psychologist. I don't know what to do with it. I don't have to learn. And I can take the approach, as in this little comic, I could just say, I taught them, but whether they could do it or not, it's not my problem. I taught them, it's their problem whether they can actually practice statistics or not. But from the 3 talks before me, we all saw importance of statistics. And we all heard that we can do quite a lot of things with numbers, and we can communicate the truth with the numbers. To be able to do that, we don't need just people who can actually do the analysis and make them available to everyone, but we also need people who understands what we are talking about. So most of my 1,000 students are going to be the ones who are users of these reports. Only a handful of them will continue to do further statistics units. So what I'd like them to be able to do is not get out of the negative mindset of this is really torture, I have to get out of it, I just want to finish this unit. So I'd like them to understand something. How we can do that, we all talk about in stats education, authentic problem solving helps them to achieve the best outcomes. In 1,000 students, I can't give them projects to work on because there are too many of them. It will be a killer for them, for me, and for my teachers group, because we can't assess all of these authentic problems for each student. So what is the best way that we can deal with it is giving them all the problems, activities, teaching, lecture notes around a context. We're not just giving them the formulas, but we are putting the problem in a domain of, let's say, sustainability. We talk about waste management, and then we talk about the paired t-test or 2-sample t-test, how we can answer that question. Very simple, but they can relate to it within the context instead of just the formula, here's the scenario, if you have this, what you have to do. And I also provide them online resources from the real problems so that they can actually improve their understanding. But I was reading today, I continue to read the book by Hans Rosling. As Andre mentioned, Hans, I was in his talk, I was very impressed with his long stick when he was doing his presentation. That was one of the best presentations I've ever had. And as I'm reading the book, I feel like he's talking to me. And one of the things he says in his book is, free access to data doesn't turn into knowledge without effort. And I have listened to my colleagues who are trying to reach out to the public and educate them about the statistics so that the data is there, but can they make any sense of it? It's really, really important. Therefore, my question, that's where I started with, how do we assess students' learning in large? When I say large, I have more than 1,000 students in my unit, and all the teaching is online. I don't see them. We do have some of the handful of face-to-face classes for students who want to come on campus. My teaching assistants are doing those things. How can we assess them? What is the best way to do it? We can't have exams because of the COVID-19 restrictions. We don't have that many rooms we can separate students away from each other. In the meantime, I want them to understand so that I can listen their thinking and I can hear their voice in the exams. That's the only time I'm going to hear their voice. Under normal circumstances, writing questions that students have to answer in a sit-down invigilated exam would be the best solution. But here under COVID-19, I can't do it. So we had to do online non-invigilated assessments. there are challenges. When I had to do it first semester, which was in June, I was just thinking, not just the students, but from my angle, how I can manage marking all of these things. We have to develop questions also that differentiate between deep learning and surface learning. And we have to have the ability to provide quality feedback to students so that the assessment is not the end, but they learn something after sitting the exam. And achieving consistency of marking when it's online, how can I do that? Discouraging academic dishonesty. I noticed after the exams, there are so many websites happily answer student questions about whatever the questions we ask them. So that's a bit disheartening to me. And I also wanted that assessment are not always in the same format. So I needed to find some different ways of dealing with it. So the way that I was able to work with my team and created open-ended questions for the final exam where students needed to enter answers. And we've used multiple choice questions and single numeric entry questions so that students get immediate feedback. When I say feedback, I mean they actually get the correct answer. They still have to do some thinking to be able to solve the problem. And achieving consistency of marking was much easier than I thought it would be. I'll show you a screen how we managed it with the Open Learning Management System, Moodle. One marker marked the same question across all the students, but because I use random allocations, not every student answered the same question. I try to keep all the open-ended questions in the same level so the assessment is the same. And because I've created many different versions of multiple choice questions and single numeric answer questions using our exams package, when I created one scenario and one set of questions, I could turn it into 100 questions with a few clicks, and that actually discouraged academic dishonesty. And assessment was not always the same because I mixed them up. And one best thing about this online assessment was no paper is wasted, no exam paper is lost. So that was actually very nice. Here's one example from where students have to enter numerical values, very simple. And here's a multiple choice question. This one had like 50 different versions. And here's a question that required entering text answer. So the question basically is at the bottom. Briefly explain the patterns on this figure. There is no one answer, as you can see. I wrote what I thought would be some of the points as the dot point for my tutors and who were marking it. And here's the student answer. The student just typed in the answer looking at the graph. It was just below that figure, and then my markers marked it. Here is another one, open-ended question. Here's the scenario I presented to students. This is the student answer, the white block after the blue, which is very bad answer, and therefore no marks were given to student. This was my thinking how we could mark it, which was available to my markers, and after the completion of the exam for the students as well. And although this is provided, my tutor also put some comments for students to improve their thinking. And here's the better answer, although it's same question. This student got the full mark, but my tutor still commented on it so that this student could improve his or her understanding after the exam is over. So feedback is there, and even if they graduate, after the graduation, they can still access it, but hopefully they actually take a copy of it. And this is the part of the markers view. You can see different versions of the exams. Remember, I had more than 1,000 students. You can see that for every different option, I had more options. I just took the top of the list. You can see 60, 70, 80 students answered it. and it was showing us what needed to be graded, and here's the zeros are the ones that needed to be graded because they're all graded right now. They are here. What was good about it also is I was able to go in after my markers marked, or just before they marked, I marked a few as an example to them, and after they finish, I double mark some of them to make sure that they consistently mark the student answers correctly. Are we there yet? Possibly not. I mean, there's always room for improvement. We could improve the quality of questions, clarity, language improvement, variety of questions could be improved, and number of alternatives for randomization, not just for the multiple choice questions, but for the open-ended questions as well. And but one thing that we are not there yet, as I said, I have 1,000 students in this class. I'm also teaching work integrated learning third year class, which we have 34 students. So we don't have many students. As academics, I mean, at least in my country, what we need to do is we need to encourage more students to study statistics. With statistics, they can do anything. As Andre pointed out, and Syed was talking about it, Professor Mohammed was talking about it, statistics is numbers and data everywhere. We need people to analyze them. So with statistics degree, students could be working any area they want to, and they can easily move between different areas as well. We have to design learning environments. I don't mean buildings or anything like that, but just in the classroom, so it enables interaction between students and lecturers so that discussion takes place. And in our lectures, I try to do that a lot, but I'm a very talkative person. When I have the mic, I usually don't stop, but I am warning my students to warn me so I can stop, so we can have some interaction. The way to do it for me is using some tools. I ask questions to students and they give answers so I can actually talk about what they said. And finally, designing assessments that help students to continue learning after the assessment finished. Last thing, this is in my door, in my office. Fail is not failure, but it stands for first attempt in learning. So if they fail once, they should attempt it again. We all fail at some stage. If we don't try, we don't get successful. We don't be successful. Thank you for giving me the opportunity to present, Saleha.
Wow, this is wonderful. And especially this last one, fail. This is the first time I saw this. It's wonderful. Ladies and gentlemen, I would like to ask you to put down all your comments and the questions in the chat to Dr. Hanif, to Mr. Sadid Rasool, to Andre, and to Aisha, and to all the speakers who are coming up, because then everybody can read those questions or comments. And if we have time in the end, I hope we do, then we can have some general discussion and some of the invited speakers will then talk to you again. Thank you so much. Okay, I will now share my screen again. And so this was this talk by Professor Aisha Bilgham, and many thanks to her also. And now I would like to invite Dr. Ria Helenius, who's the Head of Development, Communication and Information Services Department at Statistics Finland. And before I invite her, I would like to introduce to you, I would like to share with you her achievements. So she was elected to the International Statistical Institute in 2006. Currently, she's a member of not only just ISI, of course, but also of the IAOS, which is the International Association of Official Statistics, and also IASC, the one dealing with statistical education. Her current position is that she is a group leader in communication and networking in Statistics Finland. Also, ladies and gentlemen, most importantly for us, she's the director of the International Statistical Literacy Project, ISLP, which was started about, I don't know the exact number, 28 or 30 years ago. and it's been running ever since. And she's very, very, active and enthusiastic about it, and all the time promoting this project. Also, I think I should share the slide as well. So Dr. Helenius has directed this project ever since 2010. It started earlier, but I think, and she has been doing it since 2010. And during these 10 years, a worldwide country coordinator network has been established. And the project now operates in all continents, in 79 countries, and with the help of 151 country coordinators. Ria has been a part of Statistics Finland's international consultation initiatives in, for example, Lithuania, Latvia, and Egypt, and participated in many international conference sessions as chairperson, discussant, and an invited presenter. She is a member of the Finnish Statistical Society and the chairperson of the Finnish Society for Knowledge Management. Ladies and gentlemen, I present to you Dr. Ria Helenius.
Thank you, Saleha. I would like to now share my presentation.
Yes.
Could you please share it, Saleha, if you have it there?
Okay, all right. I will try to do that just now. Just give me a minute. Okay, the way I received it is this. Let me just share it now. Okay, just 1 second. Ria, this is what I have.
Yeah,
so
that's good.
That's
yes,
all
that
right.
is okay.
Okay.
Could you
all right.
put it in the presentation mode?
Okay, slideshow.
Yeah.
And from the beginning. Okay.
Okay.
All
so
right.
we can start now.
Yes.
It's my pleasure. Good afternoon, everyone. It's my pleasure. I open my videos still. Could you see me now? Okay.
We can see the slideshow, the slide.
Yeah.
That
okay.
we can see. Yes.
Okay. Good afternoon, everyone. It's my pleasure to contribute to this excellent event today. I will talk about the ISLP project and what does it mean when we say that statistical literacy is a civic skill. Next one, please. I will start with a few words about the ISLP. The International Statistical Literacy Project, ISLP, has a history of over 30 years. It operates with the International Association for Statistical Education, IASE, and the International Statistical Institute, ISI. Its main aim is to promote statistical literacy around the world. The key partners are national statistical offices, statistical societies, universities, and please don't and educational institutions. The most important actors are the 151 voluntary country coordinators who operate in 79 countries located in every continent. Professor Dr. Saleha Naghmi Habibullah is one of the ISLP representatives, and we are very proud of Saleha's work, as we can see this excellent event today. Next one. The purpose of the ISLP is to advance basic statistical literacy. Our aim is to promote statistical literacy among the widest possible audience. At a minimum, statistical literacy is an everyday skill for understanding news and media and for making everyday decisions. From ISLP perspective, statistical literacy is also a working life skill required in today's information society. It is needed in ordering, conducting, and understanding various surveys and reports. Next one. Statistical literacy for others than statisticians may mean the following. Firstly, it means understanding of concepts. It means knowing what the language of the described phenomenon is, learning to understand it. Secondly, statistical literacy is to understand the basics of statistical thinking, which are probability and randomness, measuring scales, distributive and basic statistics, for instance, mean, median, and mode. Next one. Let's look more at statistical literacy. What does it mean? It seems easy for statistician, but what about the citizen, the media, and the decision maker? Statistical literacy is having a basic understanding of the research process. For example, how are the samples made? How are data collected? And how are data modified? To be statistically literate, you also must understand presentation, the mode of presentation. For example, statistical graphics, tables, for example, how are percentages calculated? Text, for example, percent is not the same as percentage point. Do tables, images, and text describe the same thing? Next one. You have to remember these two. Evaluation of sources. Not all data are equally reliable. You always need to assess how the data are produced. Imagination is needed to combine matters and consider mutual effects. Finally, you need to be careful and compare your data. You need to be careful with your statements. Is your result a sign of something bigger or just one result? Next one. Our goal should also be to awaken the interest of those who are not naturally drawn towards statistics. Especially the youth are important. They are our future. Next one. I will conclude my presentation with an advert because we have a number of university personnel today. Please encourage your students to take part in the poster competition and tell other faculties about it as well. This is just a drop in the ocean to promote statistical literacy, but in its part, it will help to reach our common goal. Next one. A big thank you to our supporters listed here. Next one. Our responsibility as statisticians is to help others to understand statistics. Thank you.
Thank you so much. Thanks. I will stop sharing the screen. I just wanted to say that she's been doing wonderful work, and ladies and gentlemen, this time we must participate in this poster competition. I do remember that a number of years ago, it was not for the university level, but now it is also there for the university level. So definitely we should try. Thank you very much, Ria. That was excellent. I would now like to share the screen again, and let's. Have I shared it? No. 1 second. Okay. And please, I just keep reminding people that do write down whatever comes to your mind regarding statistics and statistical education and all these good things. Just keep writing in the chat so that everybody can read them and we can then preserve it later, which would be a valuable contribution from your side, ladies and gentlemen. So now, I don't know why I have not been able to, okay, I think I was not exiting that one, and now I think I can share my own. Sometimes this Zoom icon comes on top of the thing, and I don't know how to, so just let me open the thing and then try to share again, because it comes on top of it. And okay, now can everybody see my slides? Dr. Wasim, can you see my slides?
Yes, we can hear.
Okay, all right, thank you. So, ladies and gentlemen, this was Dr. Ria Helenius, and many thanks to her. And after that, now, it is time for me to invite Professor Ali Hadi, Professor and Chair, Department of Mathematics and Actuarial Sciences at the American University in Cairo. Before his talk, I would like to present to you his achievements. He is a distinguished university professor and chair of the Department of Mathematics and Actuarial Science, founder of the Actuarial Science program at the American University in Cairo in 2004, and founder of the Data Science program in 2019. Former Vice Provost and Director of Graduate Studies and Research at the American University in Cairo, a Stephen Weiss Presidential Fellow and Professor Emeritus at Cornell University in the United States of America, and a member of the Egyptian National Committee for Mathematics, Academy of Scientific Research and Technology. He obtained a bachelor's degree in 1972, a PhD from New York University in 1984. And prior to joining the American University in Cairo in 2000, Hadi served as assistant associate and full professor and also department chair at Cornell University. For about 16 years he was there. Hadi received several scholarly awards for excellence in teaching, research, and service at both Cornell University and the American University in Cairo. He has served as a former distinguished visiting professor at AUC and at Clemson University. He has been visiting professor at these universities that you can read, ladies and gentlemen. And he is an educator, and he has taught graduate and undergraduate courses in statistics, mathematics, expert systems, and artificial intelligence. And he has won several Excellence in Teaching awards. He has written 5 books, 6 book chapters, and more than 100 articles. His publications received more than 16,000 Google Scholar citations, etc. You can read all of his wonderful achievements. In recognition of his research efforts, he was awarded the Excellence in Research and Creative Endeavor Award in 2007 by AUC, and he is the first recipient of the Distinguished University Professorship at this university. There's more, you can please read it. And you can keep on reading. And now it's time for the invited talk by Professor Ali Hadi. Ladies and gentlemen, I would like to share with you that he shared with me that he had a class at this time and he could not leave this class, and therefore he has recorded this, he sent to me this presentation, which I'm now going to present to you. Dr. Wasim, can you see this presentation?
Yes, Dr. Hadia, I can see.
All right. I was just a bit worried, so I will do it again.
If you feel any difficulty, please do share the slide with me. so that I can hear it.
No, everything is fine. I will just now start it again.
We can't hear voice. We can.
Are you saying that you are not able to hear the voice?
Yes, yes. We are not.
Oh, I see. In that case, do you want me to email it to you? Or can you teach me how to do this voice? There's some option. I have to share the computer sound. I think now
Yes.
it will be all right.
Yes.
Okay,
Yes.
okay.
Yes.
Okay, now I think we can do it. Can you see my screen now?
Yes, yes.
Okay. Can you hear now?
No.
Yes?
No.
No.
We are here.
Okay, then in that case, I will email this to you. But in order to save the time, let me invite the next presenter. I apologize for this confusion. And we will do this recording, we will run later. And I will invite the next speaker right now. So the next speaker, ladies and gentlemen, is Dr. Delia North. She's Dean and Head of School at the University of KwaZulu-Natal in South Africa. And before I request her to start speaking, I would like to share with you her achievements. Professor Delia North, who hails from the University of KwaZulu-Natal in South Africa, has passionately promoted statistics education for many years at her institution, where she has been in a statistics leadership position since 2004 and nationally as chair of the South African Statistical Association Education Committee for 17 years. Amongst others, she has played a significant role when statistics was introduced into the school curriculum after the apartheid was abolished. And of late, she has been working tirelessly to link academia with industry so that statistics and data science degrees are correctly aligned with the needs of the workplace. Delia graduated with a BSc, BSc Honors, MSc, and PhD respectively from the University of Natal in South Africa. Her undergraduate majors were mathematics and mathematical statistics, and her postgraduate degrees were in statistics in probability theory. She has over 25 years of experience in the teaching and design of statistics curricula at the university. Over the years, her passion for teaching statistics has resulted in her becoming a leading figure in South African statistics education circles. She has been a member of the South African Statistical Association, SASA, Executive Committee since 1993. And she was elected to the South African Statistical Association Education Committee in 1997. And she has chaired that since 2003. So it keeps on going on and on because there's so much to her credit. She joined the Eyesight Council in 2016, in particular as recognition for her work done in statistics capacity building in a developing country. She is known in particular for the groundbreaking work that she has done to assist with the introduction of statistics at school level in South Africa, having been on a government task team to define the school curriculum, as well as being the master trainer for in-service teacher training to deliver the data handling component of the school curriculum. And I think you can read this one because it's, just like all others, she has a lot to her credit. But the thing that is written towards the end here, that in particular, she's leading the discipline as head of the School of Statistics and Actuarial Science. She was doing that from 2004 to 2010. Okay, ladies and gentlemen, I now invite Dr. Delia North to address all of us.
Good afternoon, everybody. Can you hear me?
Yes, yes.
Saleha, I'm happy to share my own screen because I've got animations and it would be easier. Should we try that?
Right.
If you're happy with that, I'm hoping I can go into presenter view. And
yes, we can.
Can you see that?
Yes, we can see it.
Great. Okay, good afternoon, everybody. And thank you very much, Saleha, for the introduction. I'm indeed very honored to be asked to speak about something I'm very passionate about, which is the relevant statistics capacity building across the spectrum in a developing country. Sorry, now I don't know why I'm going next slide and it's not going across. I wonder why. Oh, there it is. Now the world has changed so much over the last decade. We're now firmly in the fourth industrial revolution, so that it prompted the IASE in 2017 to call for global reflection on teaching statistics in a data-rich world. And the reason being that in-house data analytics skills are in high demand in the business world, so that institutions of higher education around the world are challenged to feed this ever-increasing demand for more and more job-ready statistics graduates. But at the same time, there's an extreme shortage of academics, statistics researchers, and postgraduate students to develop new methodologies as the data world is constantly evolving. Particularly true for developing countries, that there are extra challenges, and that's really what this talk is about. Because the capacity building challenges facing statistics education is in all countries, but it's more urgent and more pronounced in developing countries, because developing countries have in addition extreme shortage of funding and also often of training facilities, maybe varying levels of preparation with which students enter university. And we have very unique problems, even unique to individual developing countries. So that's really what I want to talk about, because healthy statistics systems require relevant statistics training across the spectrum, right from the bottom, basic statistics literacy, for citizenship to the top level. We need an increased flow at each level as well. We need more school leavers with an interest in making statistics their career of choice, more students studying statistics at undergraduate level, more students at postgraduate level studying statistics. But how do we do it in a developing country where we have problems with funding, and as I said, often facilities and many other problems as well? How do we do it? Well, the first thing we must know is that we must be very clear of what we want to achieve. You need to be very strategic when you don't have funding. You need to research best practices internationally. And then you need to establish collaborative relationships with international leaders where best practices are already thriving. Maybe in a developed country, but you need to adapt it to your country to be successful in your unique setting. I have found over my more than 20 years in building capacity in statistics, you can never hope to take what worked in Italy or Europe or the USA and think you can just do exactly the same thing in South Africa. You need to understand the nuances. Exactly, you know the situation in your country. In my country, for example, we have 11 official languages. There are all kinds of things I have to take into account. And I cannot just take what worked overseas, but that's a very, very good starting point. So it's only when you come from the country that you know how to adapt what's already been shown to work internationally. So I'm next going to talk and maybe reflect on what I have found to work in my own country. The first thing I think that's really important is to advocate for studies in statistics at school level. And speakers before me have spoken about how important it is for everybody to trust data and to trust and to really have an interest in studying statistics. So what I've found to be a good way to get this message across, every country has their own problems. In South Africa, the biggest problem amongst the youth is unemployment. Do you know that we have a country where more than 50% of youth are unemployed? And more than 30% of graduates are unemployed. So what that means is that there are students that have studied, but studied in areas where there are no jobs. For more than 30% of graduates to be unemployed, for me, that is just absolutely crazy. And I see it as my job to ensure that at school level, students know, school children must know, if I study statistics, I won't be one of that 30% of graduates that don't have jobs, or one of the 50% of the youth that don't have jobs. It's really important to get that message across, and it's a very powerful message. And I found that students sit up and listen when we talk about unemployment, and we maybe use our National Statistics Office data to show why you should study. And in my country, at school level, they have in high school a stream for children that do school children study mathematics, and others do basic numeracy, mathematical literacy. And often at school level, they choose to do mathematics literacy because it's easier. And I try and encourage them to stay in the mathematics stream so that they've got the option to study statistics, or maybe even mathematics or commerce, just engineering. STEM education is really important. And I use the fact of the unemployment to say, stay in mathematics, give yourself the opportunity to move into a discipline like statistics at university so that you've got a lot of job opportunities. That's a very powerful message, but it's not enough. What else I do, and I've got a little picture up here. This is what I did last year. I designed a program I call Women in Analytics. And I had this designed by a graphic designer. I just saw a fountain, and I've actually trademarked this against my data science unit because I'm trying to inspire young ladies to think about statistics as a career. In a developing country, in my country, it's not as common for female girls at school to think about a career in computer science or statistics. So I had a day where I invited girls to come to a high tea. With other words, they sit down, we serve them tea, very pretty little cakes. Now you see, I'm talking about women in analytics. You don't hear me saying boys, because I find it very inspiring to separate at school level towards the end, grade 11 and 12. I separate the girls and boys when I do my advocacy at school level, because I find that I'm trying to inspire young ladies, and the fun things I want to do, like pretty tea with little cups and nice little cakes, won't inspire the boys so much. So I find that bringing young ladies from our department and postgrad students that are PhD, MSc graduates of statistics that are successful in industry, they're young, and they're an example, and I let them give talks while we're having tea, as well as here I had Jennifer Priestley. She was the invited speaker from Kennesaw State University in the USA. She visited our country as a guest of the South African Statistical Association. So I put my Women in Analytics tea back to back with a national conference so that I could have access to Jennifer to come and speak to the young girls about studying statistics. And I'm similarly doing a boys event this year, as well as the girls going forward. But I find that separating boys and girls is very important. And you see, I say inspiring trainers. I always include teachers, because I invite maybe 20 schools to come to the Women in Analytics. They bring, maybe they can choose 20 school girls each, depending on my capacity for the tea. But I'll always include the teachers, because the teachers can carry on with a discussion in the classroom, and next year can tell the children in class, because I just find that even mathematics teachers often are not even aware of the opportunities if they encourage the school children to study statistics at university. So the next thing we do with undergraduate statistics, it's really important for the undergraduate modules to review, restructure all our undergraduate modules continuously. And I particularly mentioned service courses, which was also mentioned in the previous talks. This is the large classes like Aisha spoke about, where students are not opting to be a statistician. They may be in commerce or engineering, and they're forced to do a module in statistics. That's the perfect place to sell to a student the power of statistics. So we continuously review and restructure our undergraduate modules. But it's really important to ensure that the modules speak to the reality of our day. It's not the same module that we taught 10 years ago or 20 years ago when students used tables to look up the cutoff points for the normal distribution, etc. Now students should be focused on solving realistic problems that come from realistic context and not be treated as if they want to be future academic statisticians. We still want future academic statisticians, but we used to treat the entire class as if that was what they were hoping to do. So we need to also work with professional societies like the Society of Actuaries, maybe the Chartered Accountants, and industry to improve curricula and insight that's meaningful for the world in which the graduate is going to be working. So we continuously review our undergraduate modules, but also we need to be in touch with best practices. As I said, we'll adapt them to our country, but you'll only really be in touch if you go to the big conferences internationally. That's where you make your contacts, and that's where you become aware on a bigger arena where best practices are. And it's really important, I think, also to keep contact with your graduates, because they will tell you, your recent graduates love coming to talk to our third-year students. I invite them to come and tell the students what they've learned in their first 3 years in industry, and then to tell me where they feel we could have prepared them better. That's valuable insight as well. And while I'm saying that, another thing that I haven't mentioned earlier on that's really important is to get the successful graduates, maybe our fourth-year students, to go back to their high schools and to become an example for children at school. I even pay for their transport money for them to go home and talk at their high schools about their success, why they studied statistics and what they're doing next. Because a real example coming from your own area is extremely important. Now we have success with individual PhD students where they do thesis only, and master students. Takes about 5 years for a PhD student to complete a thesis, or maybe 1 or 2 years for a master student, but that's one student at a time, maybe working on a problem from industry, or maybe on AIDS research from our Caprisa unit, but that's too slow. We need upscale. We need more graduates to come through. We need them to come through faster. We need better systems in place. We need to plan more carefully. And that's when I started networking much more deeply with where it's working well, how to get more postgrad students through. We need less highly specialized training in statistics that don't lead to job opportunities, because we're not here only to make academic statisticians. We need more focus on statistics research that has an impact on the lives of citizens. Particularly, we need to feed the need of business and industry. And the way that we found it is through, it's going to work at my university, and this is quite a success, I think. It's a 4-year program, and we're starting next year with integrated skills development collaborative projects for postgrad studies at my university. And what we're doing, we've defined a 1-year master's by coursework, where students will, for the first semester or first 6 months, they will do short courses based on data from industry, and of course, some theoretical training as well, practical training in statistics for industry. And then in the second semester or the second half of their year course, they will be interns in companies where they will actually receive a little stipend but they will be interns and they'll get real experience for 6 months sitting in a company. And that is really important. We find that they're very excited about it because we will be able to have more job-ready graduates. Now it's stuck again. Sorry about that. It seems every now and again. Oh my goodness. Can you all hear? Let's see if it, yes. So we found this link between research, training, and industry. Student projects is really important because we can get bursaries. That's huge. In a developing country, funding is a problem. Student bursaries is a huge problem. But through bursaries, we can try and get our students not just to finish one degree and go and work, but to stay in the system and be developed further with money we receive from bursaries. And also what's helped, because we've got too few academic statisticians, we've got supervisory teams, we've got industry collaborative supervision. With other words, for these student projects in industry, we have 2 supervisors. We have a supervisor from the university, but also a supervisor from industry. So that the advantage of linking with industry in these supervisory teams is that we've got input from industry, which is really rich and good for feedback to undergrad curricula, but we get funding for bursaries. And over and above that, we have found that by working with industry in these supervisory teams and talking to industry, they started appreciating how much they needed their people in the office to get in-service training. And they started asking us to run 4- and 5-day training workshops for individual companies, which is a whole new revenue stream for the university and certainly for the statistics sector, which is very, very lucrative. And then it's helped us, and the last point is really important, it's helped us to retain our students at postgrad level. Often students finish their first degree, they can get a job, so they go. But now we convince them to stay by saying, you can study 1 more year, have a master's, and you're working at the same time because you get paid when you're an intern, and it's become very popular. But I must warn, it's a balancing act. Skills and competency should articulate the needs of industry and emerge from the strong working relationship that we have between industry and the university. But at the same time, academic quality, content and focus, as well as integrity of courses shouldn't be compromised. I'm very, very excited about the area in which we're going, but we're definitely not compromising. I did my PhD in measure theoretic probability. I love theoretical statistics, but I know that's not what we should be doing for everybody, but we cannot drop our academic quality. So in conclusion, I want to say that through linking with industry, universities in a developing country can get funding and ensure that their undergrad and postgrad programs are delivering the kind of graduates that are needed in the workplace. But through academic collaboration with other successful programs around the world and through our international associations, statistics departments in a developing country can ensure that they're developing appropriate, highly needed industry analytic skills, but they need to retain the rigor of academic inquiry. Thank you very much. That's my conclusion.
Thank you very much, Delia. This is wonderful.
Thank you.
Especially all this work in a developing country with the industry. You know, here in Pakistan also, the Higher Education Commission always wants the academia to link up with the university, but still we are not as much, still not into it as much as we should. So I think you're doing wonderful, wonderful.
4 years.
Okay, thank you very
Thank you.
Thank you very much for this. Thanks. I will now ask Dr. Wasim if the email that I sent and the Dr. Hadi's presentation, if you've got it and if it is working, if you could please start.
No, Saleha, I have no access to download the video, so I am unable to run the video.
Okay, I see, because you see, when I tried to email it to you, it said that some people need access. So I was not sure exactly what to do, so I just emailed it anyway. Anyway, ladies and gentlemen, we can sort this out. we will defer this still by a few minutes. And I will share my screen now and invite the next speaker. Okay, this was the invited talk by Dr. Delia, Professor Delia North, and many thanks to her. The next one is by Dr. Attila Goktas. He's professor in the Department of Statistics, associate professor, I think, but in the Mughla University in Turkey, or he's going to be professor, just being promoted in a few days, or has he already? Attila, you have to sort this out for me. Before I invite him, let me present to you his life achievements. He is, his undergraduate was from Gazi University, his master's from Sheffield, his PhD from Hacettepe University. He's associate professor in applied statistics at Mughla Sidki Kochman University from 2013 to 18. So I was wrong. Something I said wrong. He is professor. He has now, I think, full professorship. And congratulations to you, Attila, for this. His MSc dissertation and supervisors, the size distribution of tomatoes, and then the PhD dissertation and supervisor, Sira Nitel. I'm sorry, I can't read this properly. I think it is in Turkish. Maybe Attila will sort it out for me. Okay, he was research assistant at universities. You can read this, and then assistant professor, and then associate professor, and now professor. His administrative work, vice chair of the statistics department from 7 to 12, chair of the International Statistics Days Conference, the second one in 2018, October, and co-chair in the 2019 October conference, where he invited me as one of the keynote speakers, which was a great honor for me. Okay, English, of course, he speaks very well, and software and programming skills you can see. And now I present to you, ladies and gentlemen, Dr. Attila Goktas. So Attila, you want to share your screen? You can go ahead and do that. Attila? I don't know, maybe he's just not here for a short while. Okay, we can still proceed, and maybe as soon as he comes back, we will have a talk. And after this, we go to the next one. Now this one, okay, you've arrived?
Yeah. Okay.
Attila?
Yes.
All right, so I'll stop my sharing, and you can share your screen now.
Okay, let me share my screen. Share screen. Are you able to see my screen?
Not yet.
How will I do that?
You have to, there's the green icon at the bottom. It says share screen. And then you share your desktop or you share your slide. Okay.
Yes, I did it, I guess.
Yes, I can see that and I can hear you.
Okay, thanks a lot. Thank you for inviting me for this beautiful event. This is actually...
Attila, could you speak louder?
Okay.
Yes.
I'm using a microphone. I can hear you all very well. Thank you for inviting me for this great event. This is a great honor for me, really. Thank you. This is my first event I'm doing online on Zoom, because we had the online teaching last semester. We didn't do the teaching online exactly. We did record the lectures and sent links to the students to watch the lectures. So this is my first time. I don't really have an experience online meeting. So it's like I feel like this meeting is like a conference, and if If it was organized in Pakistan, I wouldn't be able to join it. And so thanks to the COVID, probably, it's very good indeed. Now I can have such a talk online. So my talk is the role of a statistician in today's world, data science. In my first presentation picture, I put three pictures related to data, having cars, three pictures of cars. So I will, when I end up my talk, I will tell why I have these cars in the beginning. So here are the contents, the content of my talk. So I will first try to tell what data is and data science, what the position of data scientists in data science, and what statistics and what statisticians do with data science. And in the end, I will conclude with the role of a statistician in data science. Okay, go myself to the next slide. Data are the characteristic or information, usually numerical, that are collected through observation. In a more technical sense, data are a set of values of qualitative or quantitative variables about one or more person or objects, while a datum, a singular of data, a singular usage of data, is a single value of a single variable. Although the terms data and information are often used interchangeably, those terms have distinct meaning, actually. In some popular publications, data are sometimes said to be transformed into information when they are viewed in context or in post-analysis. In academic treatments of the subject, however, data are simply units of information. They are employed in scientific research, business management, for instance, sales data, revenue, profit, stock price, finance, governance, and in virtually every other form of human organizational activity. For instance, censuses of the number of homeless people by non-profit organization. So data are measured, collected, and reported and analyzed very often. It can be visualized using graphs, images, or other analysis tools. Data as a general concept refers to the fact that some existent information or knowledge is represented or maybe coded in some form suitable or better usage or processing. Okay, how much is the data size? Just to give some information, the size of data, 1 byte equals 0.001 kilobyte, and 1 kilobyte, we were talking about 1 kilobyte in the 1980s, probably. We were dealing with computers with kilobytes, and we shift to 1 megabytes in the 1990s and 2000 between. So we were working on megabytes, that's equal 1 million bytes. And the gigabytes in the end of 1990s and the beginning of 2000 in the millennium, we were talking about the gigabyte, that is equal 1000 megabytes, and the terabytes, it is 10,000 of gigabyte, and the petabyte equals even 1000 of terabyte. And the exabyte equals roughly 1000 terabytes, and the zettabyte equals around 1 trillion gigabytes, and there is another one yottabyte equals even around 1000 zettabytes. So when we were talking about the data science is a science dealing with big data, and the big data is dealing with at least 1 exabyte. So it means the data produced by millions of people, billions of data, it should be equal to like 1 exabyte a day. how much data is created every day? Maybe you might wonder. This is 1.7 is roughly in average 1.7 megabyte of data is created every day, every second by every person during this year. In the last 2 years alone, the astonishing 90% of the world's data has been created. Or maybe in the next 2 years will be 95% of the whole data, because the data we are acquiring is a huge amount these days. 2.5 quintillion bytes of data are produced by humans every day, and 463 exabytes of data will be generated each day by humans as of 2025, and 95 million photos and videos are shared every day on Instagram. By the end of this year, 44 zettabytes will make up the entire digital universe, and every day 306.4 billion emails are sent and 5 million tweets are made. So those are huge amount of data, actually. Okay, so we described data, and now what is data science? Data science is a scientific discipline, is influenced by informatics, computer science, mathematics, operations research, and statistics, as well as the applied sciences. It's actually the science of studying scientific data, maybe. The world, okay, the world is full of data. Data is everywhere, and it always has been. Data help us communicate with each other and make sense of the world around us. But the focus today on digital data. So companies can now track consumer preferences, habits, and tendency to tailor individual offerings based on customers' online action. Data science is complex enough that it is difficult to give one simple definition. As the data becomes more intricate and complex, so does the data science definition. To put it simply, though, data science is the fact of collecting, organizing, understanding, and using data to make strategic decisions. Many companies who receive a lot of data have data scientists to help them provide a better experience for their customers and to make more practical decisions on their product or service offering. Companies that specialize in machine learning or artificial intelligence are built on data science. Okay, what about the data science hierarchy? Think of data science like a pyramid. At the bottom, you collect the data. This is the next slide. I have a pyramid. You collect, store, explore, label, and learn. That's what the hierarchy of a data science. A statistician in this pyramid does not have the mission to collect the data. The collection is not a mission. The collection is not a mission of a statistician. Maybe the statistician has a role on the third step of the pyramid to explore, label, maybe learn. Okay. An individual data scientist for modeling complex business problem, discovering business insight, and identifying opportunities through the use of statistical algorithm mining and visualizing techniques. So the data scientist should have the skill of data management, understand the data, and know analytics. So they should have those three skills: analytics, modeling, business analysis. Okay, what is statistics now? Professor Andres gave a very broad definition of statistics. I'm giving only a short definition, and which is very popular one, that is defined by the American Statistical Association. So it is the science of learning from data and of measuring and controlling and communicating uncertainty. So he gave very more broad definition of statistics. So I give a short one, which is very popular one indeed. Maybe not many of statisticians agree with this definition, but I like this definition very well. So what is statistician? What does statistician do in data science world? Statisticians actually collect, organize, although I said in the pyramid does not have the responsibility of collection, it means a statistician does not produce data. In the process of collection is like the statistician can handle the data, organize, present, analyze, and interpret the data to reach valid conclusion and make correct decisions. They are key players in ensuring the success of companies involved in market research, transportation, product development, finance, forensics, sport quality control, environment, education, and in governmental agencies. Many statisticians continue to enjoy their place in academia and research. So this picture is also given by Professor Andres Blech. It is very popular picture, very popular Venn diagram, and showing the data scientist in the position of data scientist and the statistician. So the statistician should be a business analyst as well, should have the knowledge of mathematics and statistics, and can handle data scientists. Nowadays, statisticians should also be a good programmer to be within the data science world. This is another great picture. I like it. I found it on the internet, and to show the data, so the position of data science and what the statistics and mathematics and other part of studying related to data science, which is very good one, summarizing all. Thanks for watching and listening my talk, but I will just tell one thing more about the position, the role of statistician in today's world. In the beginning, I showed you a picture of 3 cars because in my opinion, according to the research I made lately about the data science statistician, and I can conclude that this definition has, you can't find this definition anywhere. This is, in my opinion, I come to this conclusion. If a car is, I can resemble a car is a data science. If you resemble a data science is a car, a mechanic would be a data scientist. Mechanic of the car is a data science. What is statistician? What is the role of statistician for a car, within a car? So I would say a statistician is a professional driver of the car. A mechanic can drive the car, but he's not a professional. And a statistician can drive professionally the car, but he cannot be a mechanic. He can fix the car for some step, but his position is on the top to be a professional driver. And statistician, if a statistician want to be recruited in data science world, they should definitely learn their R language, as Professor Blech told about the R language is very important. And also they should know database management systems. They should learn the SQL language, and nowadays the Python programming language is very famous, and it is very good program to deal with big data. And statistician is also have the mission to learn such program to be able to recruit it in data science, today's data science. And thank you for watching, and thank you for listening my talk. And I will end up my talk. This is the end. Thanks a lot.
Well, thank you very much. Thank you very much. I love your this idea that the statistician is the driver. That's yes. Great.
This is my opinion.
Okay. Thank you. If you would unshare your slides now.
Okay.
Stop stop
is that
share.
I don't
And
have an experience. I'll try to do that from the Zoom, I guess.
it is. It should be there somewhere in the bottom line. It says stop share.
Okay, I can't do it really. I'm trying.
Okay, I think you've done it.
I did it. Okay, that's good.
I think
Okay.
you've done it, and I will now go to the next one. So, ladies and gentlemen, now it is time for me to invite Dr. Daniel Frisjemier, from Department of Mathematics at the Paderborn University in Germany. Before I invite him, let me present to you his biodata. So Daniel is, as you can see, very young, and he has been working in the field of mathematics and statistics education at the University of Paderborn ever since 2009. And since 2020, this year, Daniel is lecturer for mathematics education at Dortmund University. He received a PhD degree with Rolf Behler and with Joachim Engel, who is the current president of the IASC. And Rolf Behler, you heard about him in the previous talk, a very well-known person. And so Daniel received his PhD with these people in mathematics education in the University of Paderborn in 2016. In the frame of his PhD thesis, he designed, implemented, and evaluated a course for pre-service teachers in mathematics on developing statistical reasoning and thinking with Tinkerplots. Tinkerplots is, I also did it a little bit. It's very interesting. From 2016, Daniel works as a postdoc in the Department of Mathematics Education at the University of Paderborn in close collaboration with Rolf Behler. Together, they work on different projects and publications in statistics education, especially on early statistical reasoning and data science education. In the winter term 2017-2018, Daniel had a visiting professorship in the Department of Mathematics at the Ludwig Maximilians University of Munich. His major research interests concentrate on the development of statistical reasoning of learners from different age levels, ranging from primary school to tertiary education. Fundamental aspects in his research focus on the use of digital tools in statistics education and on data science education. He deals, for instance, with the question, how and in which way the use of digital tools develops the statistical reasoning of learners when exploring big data. All right, so this is the time for an invited talk by Daniel. And Daniel said to me that it was absolutely not, totally impossible for him to be with us at this moment in time because of other commitments, but he has sent to me his recorded video. And now I have asked my student, Ms. Aqsa Abid, to share the screen from her side and to play the video, because she was working with me last evening on this thing. And Aqsa, can you now share your screen and play this video?
Sure, ma'am. Yes, ma'am. Can you see my screen?
I can see the screen. Now let's hope we can hear him.
forward.
I think we cannot hear him because he also, last night when you played it, I was able to hear it, but I'm not able to hear it right now.
Okay,
Aksha,
ma'am.
have you done the computer audio thing on?
Yes, ma'am. Ma'am, please check again.
So yes, thank you very much for the
Yes,
introduction,
I can hear
Saleha,
him
and thank you
now.
very
I
much
can hear
for
him.
giving me the opportunity to talk to you here. And so a very warm welcome to my talk about developing statistical reasoning in primary school. So I'm Daniel Frisjemier from Germany, from the University of Paderborn and from Dortmund University. Yeah, let me make just a few remarks before to start. As a starting point, some proposals we know from international literature to promote statistical reasoning at a primary and elementary level. So a first thing is to support students in generating adequate statistical questions. This is a very important point, also to giving young students opportunity to explore data with digital tools, and of course to work with real and meaningful data. And also from a perspective of distribution, it's important that even young children and at a young age develop a global perspective on distributions rather than a local perspective. And of course, another idea is to conduct real statistical projects and to experience a data analysis cycle like the PPDX cycle. We will see this on the next slide. So I think this is more or less well known. The PPDX cycle by Wild and Funko, consisting of the 5 phases: problem, plan, data collection, analysis, and conclusions. And in this talk, and also on primary level, one concentrates on the analysis section. And here I want to pose some questions in a way. So just having the focus on this analysis phase, so we might ask ourselves, is it possible in a way to go beyond this in primary school? So for example, to explore large and real data sets, to use digital tools for data exploration, or really to conduct statistical projects with a real and meaningful data. And I want to show you shortly how we approach this idea to lead young students from working with small data sets in unplugged activities to working in larger data sets using digital tools. So this is in a way a two-step process. In a first step, our idea is to build an understanding for fundamental data operations like separate and stack. And this is then done on the example of small data sets with the material with data cards, an idea of, for example, Herodine and Conold. And then the next step, our idea is to transfer these activities from data cards to the analysis of larger data sets, and here then the software use can help in this way, the software Tinkerplots. I will introduce this software later on, but let me first go back to the data cards. What are data cards? We see here a data card as an example from the student Stropy, so you can hand out sticky notes to your students and ask them, for example, to write their name on it, to write, in a way, the variable gender. In this case, Stropy is a boy, and also you can consider a variable like how does Stropy come to school, in this way by car. So we get some information about Stropy, and we have in a way a data card for one pupil of our class, and we can imagine this of course for all our pupils of our class. Here we have an example, and we have collected the data card without any order on the whiteboard in front of the class. And then of course in the next step, the kids can have the idea, okay, it could be reasonable if I want to know something about my classmates and how they come to school, to separate by the variables in this way, by car, by bus, by bike, and by feet. And so we have made a first data operation in a way by separating all these data cards. But of course we do not see a real distribution right now. So a next step would then be to stack the data cards, and now we see what's going on. We are on the way to a bar chart, and for a little bit more abstraction, we can take a pen or something like that and then put away, and we can put away then the data cards, and we get a conventional bar graph in this way of our distribution of how our students come to school. So this, in a way, an unplugged hands-on activity, and here we can connect with digital tools. So we can now have this transition step from data cards to Tinkerplots and to build on the data analysis operations we know from data cards. And this is one way we think you can enable young students to explore really larger data sets. So just very shortly to Tinkerplots is a software which is developed by Cliff Connaught and Craig Miller. You find more information at www.tinkerplots.com. And in a way, we see Tinkerplots suitable to provide early access to the statistical and probabilistical ways of thinking of students. And the special issue in a way is a philosophy. So it takes up the work with data cards and it creates graphics and diagrams using these three operations: separate, stack, and order. We can also realize with data cards. So very shortly to a demo of the software. So we see on the left hand side, we see a data card of a student, and on the right hand side, we see a whole bulk of students. In a way, this is a real data set of German primary school students on their leisure time and media activities. And if I now want to, or if I have the question, how do the students in this sample come to school, I can do the same operations now with Tinkerplots I have learned with data cards. I can at first have a look at the bulk of students, so I see at least nothing, no distribution at all, but then I can separate the kids, or here in this way the symbols, by the categories, by car, by bus, by bike, and by foot. And in the next step, remember the steps from the data cards, I can stack the symbols and fuse the symbols. Then in a way, this is the software which supports me in this way to make a bar graph of the distribution, how students come to school. And so young students are enabled really also to handle larger data sets. So at which stages can Tinkerplots support young learners in their data analysis activities? So as we have seen, the transfer from data cards in small samples to larger samples with the software, but also with creating pie charts, paving the way to stack dot plots, or also paving the way to more sophisticated activities like group comparisons, but we do not want to refer to this in this talk. I just want to give you a very small glimpse about the design and realization of a teaching unit to enhance statistical reasoning and to explore large and meaningful data in primary school in grade 4 in Germany. So it's all embedded in the PPDX cycle, and the learning environment starts with posing statistical questions, then creating a questionnaire together with the children to collect the data in class. Then the data is imported in Tinkerplots. Finally, there are analysis and data exploration done in Tinkerplots, and finally the students can express their findings in form of posters. So very short impressions of the teaching unit. We see here two students working with Tinkerplots in pairs. We see here the students presenting their results in a way of their data posters. We see here a collection of data posters of different topics, and here also presenting all findings for all their schoolmates from a more global perspective. So that's it. Let me just shortly summarize some implications. So we see Tinkerplots as an adequate digital tool to introduce young students in the analysis of larger data sets and into more sophisticated statistical activities. The use of real and meaningful data can and should already be implemented in primary school classroom. And what is important from our point of view is to connect data analysis with Tinkerplots, with inactive data analysis, with data cards, so that both processes, in a way, learning data analysis and learning the software for analyzing the data, are connected. So I thank you very much for your attention. If you have any comments, questions, please feel free to mail me to this mail address. I'm looking very, very forward to comments, questions, and thank you very much once again, and I will close my session, my talk here, with the overview of my literature. Thank you.
Thank you, Aksa. Thank you. Could you stop sharing? That's great. Well, I think it was a wonderful talk by Daniel, and an eye-opener for many of us who are not used to this idea of statistics and statistical thinking being taught to such young people. But just see how important it is that if you are able to work with little children and to instill in them the statistical way of thinking and the statistical insight, I think this is wonderful. Okay, I will now once again share the screen from my side, and going to the next one. Ladies and gentlemen, I am now going to invite Professor Edith Sayre, professor in the Department of Mathematics and Statistics, East Tennessee State University in America. But I also see Joachim. Joachim has joined, Professor Joachim Engel. He is the president of the International Association for Statistical Education. Thank you for being here, Joachim. But first, I'm going to invite Edith. And before I invite her, let me share with you her achievements. I need to put the thing on the slideshow. All right. Edith was born in Peru, where she obtained her BS in statistics and worked for 3 years at the Bureau of Statistics and 20 years at San Marcos University. She has an MA from University of Kansas and an MS and a PhD in statistics from the University of Wyoming. She worked for 18 years at East Tennessee State University in America and is currently Professor Emeritus both at ETSU and at San Marcos. Several of Edith's papers are in the area of statistics and variability, and the list of her papers is there, and she has also written the book Introduction to Statistics in a Biological Context. At the university, she combined teaching, consulting, and research. She loves analyzing data, working with, excuse me, sorry for this interruption. I pressed something which I should not have pressed. So she loves analyzing data, working with professionals of other areas, and using R. At present, she is analyzing the data of the COVID-19 epidemic in Peru and also writing a statistics book in the Spanish language. All right, ladies and gentlemen, I present to you Edith Sayre. So I'm going to stop sharing my screen. And Edith, would you like to share your screen yourself?
I am trying to do that.
Okay, thank you.
And I have to... Okay.
Yes, I can see your screen. And okay. You can do the, please do the slideshow.
Okay. Good afternoon. Yes. I want first to thank the honor of this invitation from part of my friend, Dr. Saleha Habibullah. And I'm very pleased to have already listened to wonderful talks today. I want to talk about the interrelation between statistical consulting and research in the university environment. I really love my profession. I love statistics. And one of the things that I am more passionate about is the interaction, the opportunity of interacting with researchers from other disciplines through intramural consulting and collaboration. In all the universities where I have worked, I have, and also while I was pursuing the PhD, I have provided free statistical consulting to researchers of the university, students and faculty. And that has given me ideas for teaching, ideas for research, and also nice human experiences. Of course, one needs to be very careful on how to organize and handle that consulting so that doesn't overwhelm you. I never let them just drop their data in the office and then pick up a report. No, I sit with them, we talk about their questions, their research, I teach them how to analyze them in the computer, and if it's a short a very short analysis, of course, we finish it in one session. Of course, not that is the quick short time consulting that I do. You know, some of those cases develop into long-term collaborations in research that end up in joint paper. And from all those long-term collaborations, some end up later in, they provide inspiration for statistics in research itself. Well, when we talk about statistics and research, usually we do it in two meanings. Statistics as a tool to do research in another field, and researching statistics itself, that usually is the development or a comparison of methods or the development of a new method, statistic, estimator, test, etc. And usually one spends a lot of, some years studying the work of others before proposing new ideas or new ways to do something when we work at the theoretical level. But of course that depends also on how old is the field. I have worked for some years in kurtosis, and that is a topic from 1905, so it takes time to find new ways of doing things. But and in other fields that are newer, I'm not going to say that it's easier. It's just that you go faster to the point in which you can propose new things. In terms of consulting and research, most of the consulting cases is just to apply methods we already know that already exist, and the results are published in journals of other areas of biology, of medicine. And then the statistical explanation needs to be very short. You know, the focus is in the results in the field, and the statistical tools are briefly mentioned in the method section. But once in a while, a collaboration comes up. In a collaboration, some question comes up that we cannot solve with existing tools, and we need to develop a new one. And then the problem of consulting becomes one of researching statistics itself. And we want to publish all the details of the new tool, and we do it in a statistical journal. But I think that ideas are better explained through examples. So I'm going to tell you a story that I enjoy a lot, and was a case of a statistical research that rose from a consulting case. After many years of collaborating with biologists at East Tennessee State, we developed several joint programs involving students also. And one of those programs was the CROLL project that lasted 3 or 4 years, and integrating biology, mathematics, and statistics to study the behavior of arthropods. We had 3 teams, spiders, flies, and bees. Each team was formed by a professor of biology and 2 or 3 students that were either from biology or math, or some were double majors. And the mathematician and the statistician, I was a statistician, we worked with the 3 groups. At the beginning, we had some training sections of basic tools of analysis, and we included some tools of spatial point pattern analysis, because we knew that that type of data was going to be collected in the experiments. And this story belongs to the spider group. And several experiments were done, but specifically this was an experiment of preparing colonies in little squares that of 16 by 16 centimeters that had like a net, and they put a mother spider with all her eggs and waited that the colony developed. And then in 4 specific days, the first day that the colony show up, and then at day 23, 35, and 48, every 4 hours, they located where each little spider was and where the mother was, and recorded the information about their location. We did a lot of analysis on the data, but that was a group that I enjoy a lot working with, and we had a lot of interaction. We push each other to think by questions, and the brainstorming sessions were really a pleasure in that specific group. You can see the picture there. And one day we were talking and looking at the picture, one of the many pictures that were produced was that, and the biologist, in one of those pictures, the biologist said, I think they prefer to be at the border than at the center, don't you think? Can you test that? So I answered, well, maybe we can divide the square in center and border and do a chi-square test to check if the observed number is not too far away from the expected value according to the size of each area. And then the mathematician said, but you told us the other day about the G function to check for clustering. Is there another function that we can use for this? I said, well, not that I know, but I am no expert in spatial statistics. So the biologist asked, well, if there's no function, can you define one? And I said, sure, but honestly, I was not too sure I could do it. So I started looking again at the G function that I had told them about, that is used to study clustering. And it has a very formal definition, but if we look at it at detail, it's actually just the empirical G function is a cumulative distribution and of the distances to the nearest neighbor. And if you look at the picture below, you see this is not of spiders, this is of bees, where the bees perform dances to communicate information about the location of the food source to tell the other bees. The explorer bees tell the other bees by means of dances. And where do they dance? In the hive. And so you see that they are very clustered. They are one very close to the other ones. And so the short, if you calculate the distance to the nearest neighbor, those distances are going to be, most of them, very short. So if you think of the distribution function, of course, in the small values of the distance, you're going to see high frequencies and you go very quickly up in the distribution function. That is the black line. And we compare it with a theoretical G function that somebody developed under the assumption of complete random spatial randomness. So what can we do that to translate that to the border? Okay, we could calculate the distances to the nearest border and find the cumulative distribution of those distances. But we need the theoretical B function to compare it. Okay, so the first thing I did was to write code in R to calculate the distances from the observed points, the spider locations, to the nearest border of the square enclosure. But how is the theoretical B? Sometimes when I don't have an idea of how something theoretically behaves, I do a simulation to have a first idea about that. So I did that, generated a lot of points, calculated the distance to the border, and look at the shape of the curve. And fortunately, it was not difficult to come up with an expression for that curve. But that was not a formal deduction. So we needed one. And we wanted to really involve the student in the team in the thinking process, in the research. So I told her, well, now your task is to think how to do a formal deduction of the theoretical B. So she took the problem home, and after a few days, she came with a very interesting idea. She said, think of the enclosure as this big square and think of a smaller square, like you have shrunk the big square, and that the distance between the borders is D, okay? And the proportion of points that are, if it was totally random, the proportion of UC, it's 1 minus the area of the smaller square compared to the area of the big square. So she wrote a general expression and she made it particular for the case of the squares. But she had gone beyond that and she told us, well, I got carried away and I also did it for the circle, for the rectangle, for the cube, the sphere, etc. So we were very pleased and we said, okay, let's see how we would interpret that theoretical the empirical and theoretical B. So I created three hypothetical examples, very close to the border, all over the place, and far from the border. They are randomly generated, but with a specific intention. And how does the empirical B look like? In this case, the distances to the border are short, so you go very quickly up in the function, and you're above the theoretical B. In these ones that are all over the place, totally random, it's very close to the theoretical, and if the distances are large, there are few short distances, so we're going to be below the theoretical B. And then the student asked, do you think we could publish this? I said, well, we work with the square enclosures, but that is very particular to the experiments with the spiders. Most people in spatial statistics work with maps. If we are, and not with geometrical forms. So if we're able to extend these to maps, we don't need it for the spiders, but maybe we can publish it. And so two new difficulties. So first thing, I look for real examples to see if it was worthy. And yes, I found 3 states in which the little towns and cities, those are the location of the census locations according to the Census Bureau. And we see 3 very different situations. And so, but now new difficulties arrive trying to work with maps. And the two are, how do you derive a theoretical B for a map that is not, you know, the map is not a square, a rectangle, or a circle. And how you, also, when you receive the data of border of maps, they don't give you all the coordinates. When there's a straight line, they only give you the coordinates of the extremes. And I needed all the coordinates of all the points in order to find the distance to the nearest border. And so those 2 problems were solved by the mathematician in the team. She did first, I gave her a map like the first one with a lot of gaps because that is the information I could download. And she did Hermite cubic interpolation using MATLAB, and she returned me a complete map with all the data, all the borders, the points in the border. And the other one was more difficult. It was, she wanted to apply the idea of Chelsea, of the student, to shrink the geometrical form to work with the areas.
Edith, can I interrupt? I would like to request you to please just make it a bit shorter because we are running out of time.
Okay, I'll do it.
Thank you.
Well, let's finish. So she worked on that, and then I returned and I worked more statistics to create confidence bands by simulations. We've did the study of the B function for the maps, and we published the paper on spatial statistics. So we put all the commands in R. If somebody wanted to use them, they have used it in an ecological study. And also we returned to the problem that originated the question, and we applied for the, not only the spiders, but also for the bees. And it was a pleasant research, really, for several reasons. And I thank you for the invitation. Happy International Statistics Day for all the statisticians in Pakistan, and many future successes for the PISTAR Institute. Thank you.
Thank you very much. Thank you very much. That was very, very interesting and insightful. Now, ladies and gentlemen, I want to just say a few words before we go to the next presentation. As you can see, it is only 14 minutes left, and I apologize to everybody for this. And I would like you to bear with us, and please let's just continue until we complete all the invited talks. As far as the panel discussion is concerned, I think that will have to be in our next event, whenever it may be scheduled, because we will not have time for that. So my apologies, and it's my first time doing it in this way. So I hope that it will be possible for you to forgive me for this. But at the same time, I think you will be very happy to hear so many different eminent statisticians sharing their life experiences. And as I have learned so much today, I'm sure many of my colleagues and students must be feeling the same way. So now I'm going to share my screen, and I want to say that we have two talks now. One is by Joachim. He is going to present his talk, and the other one, the only other one that is left, is the one which is by Professor Ali Hadi. But you do remember that there was a problem. Then in the next one is Joachim. But I did ask, I called Professor Hadi just now, and although I think he was in his class, but he picked up the phone, and I said that there is this access problem. So he said that, okay, he will send it again. So now I am asking Aksa if you have been able to access this recording. Aksa,
Yes,
can you tell me?
Yes,
Okay,
ma'am.
then in that case, please, if you can run it. Then after that, as the final talk for the day, I will request Professor Joachim Engel, the president of IASC. So first, Aksa, you may please share your screen and start the talk by Professor Ali Hadi.
Good day, everyone. Good day, everyone, and greetings from Cairo, Egypt. I wish to thank the organizers, Dr. Saleha, Habibullah, and Dr. Mohammad Hanif, and all of you for organizing such wonderful conference. I wish I were able to be here in person, but unfortunately, I'm teaching at the same time, so I'm offering you these recordings, and please stop me whenever you think that I go beyond the allowable time. This is the outline of the talk. I will talk about only the first 3 items because of time constraints, but I'm leaving the slides for item number 4 and 5 in the slides for those of you who are interested to read them. I will start with some pictures from farming that farmers used to use in the recent past. I'm not talking here about ancient past, I'm talking about recent past because I myself actually have used these tools. And I would like to know how many of you actually are able to recognize these tools. So let me start here by the first one, which is a plowing tool that used to plow the field in farmer. And as I mentioned, I used this tool myself. And this is another tool here, which is used to lift water. And this tool is now in a museum. As you can see, I'm standing next to it. And this is another tool that is used for threshing wheat. I'm talking here about tools that were used in Egypt, but I'm sure similar tools will be used elsewhere in the world. This tool is also in the museum. And there are many other tools that I can share with you. You can see them yourself if you search the Google winnowing tools. All these tools are replaced by one single machine today, which does everything in one place. But these tools were used to be called technology at the time when they were invented, just like what we call technology today, like robotics or the self-driving car and so on and so forth. These tools, which were very useful at the time, many of them, if not all of them, went into extinction. And this will lead me directly to the most important bottom line of this talk. The conclusion is that if we statisticians do not adapt ourselves to the needs of the world in which we live, we will go into extinction. Whether we like it or not, statistics is now being replaced by data science. Let me give you 2 examples. The first one that these pictures give us is it gives us a classical but not Fisherian classification problem. Suppose we wish to classify each one of you into one of these two groups. Either you know the picture, that's group 1, or you do not know the picture, that's group 2. And we collect 2 categorical variables only. The first one is whether you were born in rural or urban areas, and the second one, whether you are young or not young. Example 2, suppose that we wish to know whether 2 quantitative variables, X and Y, are correlated. Students will respond immediately by computing and interpreting the correlation coefficient in conjunction with the scatter plot of the 2 variables. And here is an example of the 2 variables where we have a sample size 200. You can see clearly that the 2 variables are linearly related, positively related, and there are no outliers. So the correlation coefficient here will be interpretable and meaningful in this case. But what would happen if the sample size go to 1 million? And 1 million actually is not big data in nowadays terminology, it's still small data. If n increases to 1 million, this is what you will see. So you can see what we call the cluttering effect here. And this cluttering effect, large data or big data, represent problems both to statisticians and to computer scientists. Okay. But what if the 2 variables are qualitative? How to measure their correlation or association? How to identify outliers in qualitative data? How to generate simulated data, simulated qualitative data with known properties? There are partial answers to these, but nearly all of them are much less known to statisticians than the correlation coefficient. So how many statisticians cover these 2 examples in our statistics courses? Since we do not want to know, we do not want to go into extension, we must adapt ourselves to the needs of the world in which we live. Simply stated, we have no other option but to adapt, otherwise we'll go to extinction. So the only question left now is, what do we need to do to adapt? We need to change our thinking about our profession. In other words, we need to have a cultural change, complete cultural change. We also need to revolutionize our statistics curricula and the way we teach them. So back now to the first classification problem. We collected 3 variables, as I mentioned. One is the age, the second, where do you live, and the response variable here is whether or not you recognize the picture. So all 3 variables are qualitative, including the response variable. And the question is, which statistical method should we use to solve these classification problems? Of course, we cannot use the Fisher discriminant analysis. The data are not multivariate normal, they're not even quantitative.
Thank you.
And the groups may or may not have equal covariance matrices. And actually in this case here, the means, the variances, covariances are not even defined for categorical data. So question number 1, which regression methods is suitable in this case here? I'm listing for you 17 different regression and the classification method that can be used. And the question number 2, how many of these methods do we actually teach in our statistics curriculum? Okay, in my judgment, very few of them. But the answer to this classification problem is very simple. You can use simply using CART. But how many of us include CART in our statistics curricula? We do need to change. What do we need to change? Number 1, we notice that we focus heavily in theoretical mathematical aspects and continue to discuss things that are no longer necessary. For example, different formulas for computing the variance of just one variable. Or what is the optimal number of bars in a histogram? Or how do we compute angles when we construct a pie chart? Many of us still spend some time talking about these things, where in fact the computer can do the things very readily for us. We do not distinguish the different types of our audience, whether we teach the majors or non-majors. These two different audiences should be taught differently. We assume difficulties away. We concentrate very heavily on continuous data, normal distribution, equal variances. But what about categorical data, nominal data, text data, images like photos, MRI, videos, voice data, or even unstructured mixed data that contains all these types, like data streams. Okay. We continue to insist on using obsolete and very expensive software packages. We should move to the more modern, free, and multi-platform languages such as R and Python. We do not teach our students to think critically. For example, why do we choose H0 as the no effect hypothesis? What would happen if we switch H0 and H1? Why do we control type 1 error and only hope that type 2 error will be small? Would least square continue to be blue when some of the assumptions are violated? We use methods that depend on ridiculous assumptions without explicitly mentioning them and without verifying them, without discussing tools for the validation of these assumptions. We continue to insist on using very small data sets, while big data represent many challenges for both statisticians and the computer programmers. For example, computing speeds. The scatter plot that I showed you might take some time to show up on the screen. So talk about here complexity, how long it takes to compute things. We also can talk about cluttering. The statistical inference. When n is large, everything is significant. You will always reject H0 if you have a big data. Why? Because, as you know, the standard error depends on the sample size, and the sample size in the denominator of the standard error. So the standard error will be just simply be 0. So H naught will always be rejected in large sample. So there is no need for statistical inference there. Cluttering problem that I just talked about. So what do we do? What further we do need to change here? We need to communicate with other related disciplines, such as computer science. These two literatures use different languages and terminologies about the same thing. So for example, what we call variables in statistics, they call attributes or features. What we call observations, they call objects. What we call outliers, they call anomalies. What we call modeling, they call structural learning. Parametric estimation, they call it parametric learning. Classification, they call it supervised learning. Clustering, they call it unsupervised learning or semi-supervising learning. Here are some terminologies or tools that were contributed mainly by computer scientists, not by statisticians. And in all of them, we missed the boat, we missed the bus here. You know, when neural networks was introduced, we thought, oh, no, neural networks is a black box. We can't use it. Okay, data mining, deep learning, visualization, machine learning, all the things here are contributed by computer scientists. Unfortunately, few statisticians contribute to this area. We need to adapt and modernize our discipline and ourselves to meet the continuing challenges that we see or they face in the real world. How do we adapt, embrace, and contribute to the newly developing multidisciplinary field of data science? So I will stop here, and I thank you for listening. But those of you who are interested can continue and read the slides, and I will very much look forward to hearing the other recordings in this conference. And if you have questions, please feel free to contact me. Thank you very much.
Okay, thank you very much, Aksa. And I'm sure everybody must have felt like me that it was an excellent talk. And now, ladies and gentlemen, I will once again share my screen and request Professor Joachim Engel to address the audience. But before I do that, I would like to present to you an outline of his life achievements. Professor Joachim Engel is a professor at this moment in time at the University of Education at Ludwigsburg, Germany, Department of Mathematics and Computer Science. As I have said, he's the president of IASE for the term 2019 to 2021. His previous positions are as follows: visiting scholar at the University of California at Berkeley, Stats Department, August 2016 to January 17. Professor at the Leibniz University, Hanover, Germany, Department of Mathematics from 2004 to 2006. Lecturer at the University of Education at Ludwigsburg, Germany, 1994 to 2004. He was a research fellow at the University of Bonn in Germany, Institute of Economic Theory from January 1993 to 1994. Also a research fellow at the University of Heidelberg in Germany, Institute of Applied Mathematics. Visiting assistant professor at the University of Michigan in America, in Statistics Department in 1988 to 1989. I don't think, Joachim, it could be 1889, but I made bigger mistakes than this little one. It looks very nice, actually. And also he has been a school teacher at the gymnasium in Herborn, Germany from 1982 to 1984. So what is his teacher preparation? They include this certificate. You can read that. Actually, it is in German, so I better not try because, well, but it has an English translation, academic exam for high school teachers from the University of Bonn in 1978 to 1980, sorry. Then the classroom exam for teachers. And then what are his research interests? Statistics and probability education, multivariate statistics applied in social sciences. He's also interested in data smoothing and non-parametric curve estimation, mathematical modeling, inferential reasoning, multimedia learning, risk perception, and communication. So he has doctoral students, their names are written there. He's been the principal advisor for these PhD students. And it goes on, and you can read it. PhD in 1988 from the University of Southern California in LA. And dissertation, density estimation with HAR series. And then also these Master of Science and the diploma. And what is the thesis title? On principles for optimality in stochastic control. So ladies and gentlemen, it goes on, and it is a great honor for me now to invite. Please do keep reading because I'm wanting you to read this at the same time. Okay, member of advisory board, associated member, German Center for Teacher Education.
Okay.
And it goes on.
Yeah.
So now I invite Joachim Engel to present his invited talk.
Okay, thank you very much. Our time is short, and I will try to take not too much of your time. First of all, I have to apologize. I do not have slides prepared, so I will talk to you directly.
That is no problem. That's all right. It's fine.
My great thanks go to Saleha Habibullah and the Pakistan Institute for Statistical Training and Research for organizing this wonderful event on occasion of the World Statistics Day. And for giving me the honor to be an invited speaker. Okay, I've been asked to talk about future directions for statisticians of developed and developing countries. Let me start our outlook towards the future with looking back to our history. The discipline of statistics emerged in response to the perceived need to understand phenomena of the world around us better, and to address important problems in a broad range of disciplines which involved uncertainty. Early pioneers came from a wide variety of backgrounds and invented new mathematics and new ways to look at the world. As an example, look at the early members of one of the earliest professional statistical organizations, the Royal Statistical Society in the United Kingdom, founded in 1834. The members came from diverse backgrounds that included politics, law, history, physical sciences, philosophy, religious institutions, the army, art, journalism, medicine, as well as economics and mathematics. They were driven by a desire to develop and apply new methods to help understand the world around them and to act to make things better. The early basis of the Royal Statistical Society was in social issues rather than in mathematics. And it lists among its founding aims the collection and classification of all facts illustrative of the present condition and prospects of society. So social life and politics were intended to be better understood. The desire to collect information to inform action is illustrated vividly by the work of Florence Nightingale, whose 200th birthday we just celebrated this year. Yeah? Known as the nurse with the lamp, but you could also describe her as the lady with the data. She was the first female elected member to the Royal Statistical Society. And she pushed forward major changes in hospital hygiene and sanitation in general. So concern for this, the social situation of its inhabitants, of people, were at the beginning when statistical organizations were formed. The challenges faced by the modern world today are at least as difficult as those faced by early pioneers. Yeah, think of COVID or climate change and many more. Yeah? And unemployment, militarism, and whatever. And the range of people engaged and the variety of investigative methods and analytic tools have grown and continue to grow in a dramatic way. Just think about our last presentation by Ali Hadi, yeah, and the tools that data science provides to us. We live in a world awash with data and with freely available software. Skills to use information technology, to search for information, to visualize and explore data are of increasing importance for the advance of science, of health services, of societies in general, and for public decision-making and private life. Digital media and the accessibility of data are changing our access to information and are also shaping the political discourse. Non-partisan organizations have gathered a wealth of information that anyone can use for information and debate. From the United Nations work on sustainable development goals to measure social progress, through national statistics offices gathering information on employment and income and migration, to non-government organizations monitoring climate change and citizens' health. This is a huge progress against times when the true state of society was kept as a state secret. Set against this is a long history of advocacy for the role of evidence to promote social justice, freedom, and the progress of nations. As early as 1792, the French mathematician and philosopher Condorcet argued for the importance of informing citizens about governance and presenting evidence about the true state of society in order to raise awareness of injustices and structural and social inequalities. Wherever we as statisticians work, in government, public health sector, administration, non-government organizations, in academia, education, to address challenges of the future, we need data and analyses we can trust. Better data, better decisions, better lives has been the slogan to promote the United Nations Sustainable Development Goals. By providing trustworthy data and presenting transparent, trustworthy analyses, we as statisticians play a vital role in empowering citizens in our society to participate in public decision-making processes and thereby strengthening democracies. The current pandemic, occurring alongside the decade for action on the United Nations Sustainable Development Goals, has brought into sharp focus the critical importance of trustworthy official statistics. A particular feature of the current climate is the danger of false statistics that can mislead and result in poorer decisions. Such false statistics may be the result of an inadequate design, implementation or communication, or a deliberate attempt to deceive in order to serve a vested interest. Either way, false statistics result in poorer decisions and therefore in lost lives, weaker economies, less just societies, and a future for our children that is not as sustainable as it could be. To confront misuse also implies transparencies, providing an honest account about the true state of the world. It requires access to data, courage also to contradict the political dogma, for example, in terms of the climate change, if people do not want to realize that, yeah? Against all statistical evidence. To summarize, the discipline of statistics emerged in response to perceived real human needs that the world is facing. The challenges we are facing today are very big. In whatever capacity you work, in academia, mathematical statistics, as a government statistician, private industry, in education, as a data analyst, today we have data and we have the tools and we have increasing knowledge how to analyze and understand this data. Therefore, let's get on and use all these tools and instruments that we have to make this planet a better home, a home where people can live in peace, freedom, and dignity. So, these are my last words. Sorry that I didn't have a slide. I thank again all of you for listening, and thanks again the organizers for organizing this spectacular event being spread around the globe. As far as I saw, we have participants from almost all continents. Okay, thank you.
Thank you so much. Thank you so much, Joachim. That was wonderful. I'm so grateful to you. Okay, I will now share my screen. And ladies and gentlemen, I will be now presenting to you the last part of this thing. We have still a few things to come. I would now be requesting my colleague here at PISTAR, who is otherwise assistant professor at the Lahore College for Women University, to render a presentation regarding Professor Dr. Munir Ahmed, who passed away last year and who was my PhD supervisor, so many of my colleagues' supervisor, and a true mentor. So over to Dr. Sharqa Hashmi for this particular presentation. I will stop sharing my screen, and Sharqa, you can start sharing. Dr. Sharqa.
Thank you so much, Dr. Saleha.
Yes. I cannot see the screen, Dr. Sharqa. I mean, your slide.
Right. Are you listening? Are you viewing or not?
Not yet. No.
No.
You want
but
me
I shared. I shared it.
But no, but we don't see it. So let me share the slides from my side, if that is all right for you.
Okay.
Because we don't see. Maybe you can stop share and share one more time.
Okay.
In the meantime, I am also downloading it from my side, because
okay.
You sent it.
Now it's shared.
Okay, all right. Please go ahead.
A brief history of life and work of Professor Dr. Munir Ahmed. Introduction about him. Professor Dr. Munir Ahmed was born on February 22nd, 1932 in a respectable Muslim family of Sialkot, Pakistan. He was a legendary academic, outstanding statistician, exceptional professional leader, generous philanthropist, and a highly respected personality in the statistics community. His educational history includes he obtained bachelor's degree from Murray College, Sialkot, and his master's in statistics from the University of Punjab, Lahore, Pakistan in 1954. 5 years later, he obtained a postgraduate diploma in statistics from Aberdeen University, UK. The PhD degree in statistics was achieved from the Iowa State University, USA in 1968. Professional career. Dr. Munir Ahmed commenced his career in 1955 as a research scholar and lecturer at the University of Punjab. After completing his PhD degree, he served as chairman of the Department of Statistics at the University of Karachi from 1971 to 1973. He worked as Tripoli University, Libya during the period 1973 to 1977, and later he served at King Fahd University of Petroleum and Minerals, Saudi Arabia from 1977 to 1994. Professor Dr. Munir Ahmed served as Dean, Faculty of Mathematical Sciences at the University of Lahore from 2000 to 2002. In the year 2002, Dr. Munir Ahmed was appointed as Rector at the National College of Business, Administration and Economics NCBAE, where he served until his dismiss in June 2019. Dr. Munir Ahmed's vision. One of his dreams was to make Pakistan a statistically advanced country by satisfying all requirements. He also led the vision of introducing common statistics undergraduate curricula in the tertiary institutions of Islamic countries. Promotion and usefulness of official statistics. Official statistics can be used for preparation of planning and monitoring of its performance at different steps. Sustainable development goals. During his last days, he was concerned. During his last days, he was concerned about the development of Pakistan. He was seriously working on the Sustainable Development Goals. Through the nationwide network he created under ISOS, he has been driving hard to procure relevant data to determine the indicators on each of the goals. Legacies. His legacies includes Islamic Countries Society of Statistical Sciences, ISOS, Pakistan Journal of Statistics, PJS, Journal of ISOS, Journal of Applied Probability and Statistics, JAPS, ISOS House, Park Institute of Statistical Training and Research, PISTAR, a large number of statisticians. Dr. Munir Ahmed passed away while serving as the rector of NCBAE on June 29, 2019 in Lahore, Pakistan. May his soul rest in peace. He left behind his family and a large number of students and colleagues with a strong belief in him as a leading academic researcher, mentor, teacher, and well-wisher. His family was always behind him and inspired him to the cause of ISOS. He takes account of every single thing Al-Quran. And Dr. Munir Ahmed says, statistics is one of the holy words of God. Thank you. Over to you, Dr. Saleha.
Thank you very much, Dr. Sharka. That was very, very nice. If you would unshare the screen, then I will start sharing.
I stopped.
Okay. Thank you. So this was the presentation by Dr. Sharka Hashmi. And ladies and gentlemen, immediately after this, we have a video presentation that has been prepared by my another one of my very dear students, Ms. Kamal Aslam. At this moment in time, it's a very, very short one, so we don't have to worry about the time. And I would like to request Aqsa. Aqsa, are you able to share this one now?
Yes, ma'am.
Okay. Thank you so much, Aksa. Ladies and gentlemen, for those who did not know Professor Dr. Munir Ahmed, we thought that we would share with you a little bit about him in the form of the presentation given by Dr. Sharka and in the form of this lovely video, lovely little video that has been created by Kamal. And now I think we are almost completed, but of course it is now my time for me to thank every single one of you from the core of my heart. Actually, I don't have words to express.
Dr. Saleha, please continue.
So,
we know you are too emotional now. Please continue.
okay, so I also want to have this one slide saying concluding remarks. So what is the concluding remark? Should we or can we make the PISTAR celebration of the World Statistic Day as an annual event? So I would like to request my colleagues to please unmute their mics and let me know, what do you think? Hello?
Yes. Yes, I think so. There should be an annual event of World Statistics Day. This is a very good platform.
Thank you very much. Thank you. Now I will continue. You can mute the mic now, sir. Thank you very much for that. I want to now, because of the recording, we need to do this. Now I want to go to my next slide. It occurred to me that the United Nations has announced this as every 5 years. So what we could have instead of this one, we could have this one. We could, if you agree, we could have the PISTAR Congregation of World Statisticians every year. If you agree, we can have it. We had one today in connection with the World Statistics Day. We can have one next year, one another year, then another one, then another one. And then when it is 2025, it would, I think, coincide with the 4th World Statistics Day. That would be October 20, 2025. I'm quite sure the United Nations will be wanting to celebrate that one too. I want everybody to know that we got the formal permission from them for utilization of their logo. My colleague, Dr. Wasim, advised me to do that, and I'm extremely grateful to him for this. And they are also very happy, and now our event is also on their website. And I think they might ask us to send this recording also. We may edit it a bit wherever I have made some blunder, and then maybe we can send to them the edited version. This is the second last slide. Thank you all for being a part of the PISTAR celebration of the World Statistics Day 2020. I'm extremely grateful to all my colleagues, senior colleagues, renowned statisticians, working diligently for, for better statistics in this world, and or to, to give us so much of your time to prepare these beautiful, extremely horizon widening and educational talks. And also I want to thank every single participant, every single one of you for being here for these 3.5 hours. If anybody wants to write to me, these are my 2 email addresses. I'm a professor at Career College for Women in Lahore, Pakistan. I'm going to stop sharing the slide, and I'm going to, I want everybody to know, please accept my apologies that I did not announce it earlier. But, I was taking all these screenshots that you did see in the middle so that we can make a nice video like just now you saw out of the photographs of Dr. Munir Ahmed. we are also in the habit, Kamal, my student, is in the habit of making such beautiful videos out of these screenshots as well. So thank you very much, ladies and gentlemen. This is the time to say goodbye, although I will be here for maybe 15 minutes more, 20, whoever wants to speak informally. But in the formal, as far as the formal proceedings are concerned, on behalf of Professor Dr. Mohammad Hanif, Dr. Alia Ahmed, who's also the daughter of Professor Munir Ahmed, and also the chairperson of the ISOS Executive Committee at this moment in time. On behalf of Mr. Muhammad Iftikhar, who is the Executive Secretary of ISOS, and also he helps tremendously in me and my team for doing the PISTAR work. And I thank every single one of the other people in the ISOS and PISTAR community who helped me and my team with this today's program. Thank you very much, ladies and gentlemen. It is time to say goodbye, and Allah Hafiz.